No problem. So I would recommend generally I would recommend to use chat as the first medium. But yeah, that's okay. Can have either
And
ways.
if they have any, like if you have any queries, then let them raise their queries with that. Okay.
Yes, please.
Yes, sir. You can.
So Zach, great. Great. Great, guys. So thank you, Manjunath sir, and thank you, Alvas Institute of Engineering and Technology, so providing the opportunity. So let's start, and thank you all for joining it. Warm welcome and a very good evening for everybody. Hope everybody's in India, so that suffices. Great. Ramesh, give you all a very good introduction to me myself, so I don't need to give my introduction again.
Thank you, sir.
So the topic that great. The topic that we are having this evening, obviously we have two different topics. So the first topic or the first session will be discussing about PKI, public private key infrastructure, and other security protocols, authentication protocols, zero trust identity, and so on. Again, frankly speaking, guys, when I was studying these topics in my student life or when I was starting my career, these topics did sound a bit boring for me, and I think it would for some people, definitely. That's why I want this overall session. Every session I generally have it very interactive, and I want this session to also be very interactive. So instead of following a conventional sessions or seminar or a webinar, whatever the conventional method is, so I've taken a small story over here. Okay, I think all of you guys, all of your faculties, fellow faculties, or in other organization, you or other institutions, you would have find some startups within your organization itself. So I'm pretty thankful for Alvas because they have multiple startups in them. I have been a part of a couple of other sessions with Alvas and I've interacted with those startups as well. So do you guys in your organizations also have startups by any chance? Do you guys work with startups? Guys can respond on the chat. Yes, sir. Okay. Is the chat enabled, sir? Everybody? I think no.
Chat is enabled. Yeah. Even mic is enabled for them.
Okay, great. Yeah, great. Great. So we have different startups. Okay, so I'll be taking the same theme as startup. Before going to the theme, do you think these startups? I was just referring yesterday's session as well. Samat did give a very good session yesterday. So again, going back to the same mechanisms. So do you think the startups that we have today, pretty much Karnataka or more precisely Bangalore has become a startup capital of India, the whole. Do you think the startups do have security in them? So how secure do you think the startups are generally? How secure do you are secure, guys? A little bit, okay. Okay, yeah. So we'll go with a little bit as an option. So yeah, frankly speaking, I've also been interacting with multiple startups for security assessments and a couple of other assessments as well. But usually, startups' idea, the purpose of the startups is to achieve some problem statements in a very general cases, and because of their hurdles, because of their presence in the industry, most of the time the startups don't concern or don't take security as their major concern. Because let's say take example of any startup. Let's take example of Swiggy or a food delivery app or any other application or Ola or any travel apps. The purpose of these apps are basically to perform some actions. The example of food delivery or Instamart, where their intention is to ensure or make the user order of food with a less amount of time, or connect to a cab with a less amount of time, with less amount of interaction. There's no complex calculations or complex programs involved in it, isn't it? They make it very simple. So they are very least concerned about security from the day one. Okay, to discuss the topics, today's topics, the PKI and so on. So I'm drafting a very similar startup idea. Let's take example of this imaginary company called Finser. Okay. So it's just a very simple startup application which I've taken to explain our topics for the whole today sessions. So this FinSub application is a simple online payment application. You can consider something similar to a Paytm or a Razor Pay or Phone Pay, anything like that. Okay, it's a very simple application. This application allows users to make as simple as that. Nothing fancy. No, don't take it with social networking or social media websites and all. It's a very simple application which will allow you to download an application on your mobile phone. So in backend, it's an application hosted on it has cards involved in it, bank account involved in it, and it will allow you to do the payment. Okay. I'll first draft you the basic structures or basic feature that this web application provides, and then we'll go forward. Okay. So this application or a startup application basically allows you to access the application via mobile application, as well as browser. The developers have deployed this application on a cloud networks. Assume let's say AWS or some other cloud. In the backend, the employees of this application can also manage the transaction, because you need supports, right? So like say if there's any problem, you will raise a ticket, and there should be some people to see the transactions. There's also admins like that. And also we have some APIs for the interactions. Okay, very simple as that. It's a very simple application, mobile app, which will allow you to do online payments. Okay. So far, is the background clear for everybody? Do you have any doubt in the background before we proceed? Great. So let's take a case study. So the whole session, I wanted to have it from a case study point of view. We have multiple concepts that we'll be discussing in today's session. And all these concepts, instead of just giving you a definition, use cases and all, so I'll be taking up a real world use case, and we will understand the case study. What is a problem statement in that case study? How are we using a particular technology to meet that particular, to secure that particular aspect? That's what we'll be following towards. So let's say the startup app that the company has developed. This is how, from a nutshell, the web application or the flow looks like. There is a mobile app where a user will click on Pay Now, and his staff will go to internet, and from internet it goes to the firewall, and then it goes to the backend server. Any actions need on DB, it will carry out over there, and there is an admin, a backend admin. They can also talk to the servers for ticketing or any troubleshooting and all those things. Okay. Now, here, if you look into the technical aspects, this application is running on HTTP. The website is running on HTTP. All the traffic are happening through HTTP. The traffic from admin to the systems happens to Telnet. Login authentication is based on username and password. The server, basically the internal systems, trust anything that is coming from the network. Whatever is coming within the network, it will automatically trust everything. Okay. I hope again this background is clear. Now I have a very simple question for everyone. You guys understand this architecture, understand the base of it, and you guys tell me, within this case, what can go wrong from a security standpoint? What do you think can go wrong? Sorry, ma'am, come again. HTTPS? Yes. Yeah, one
Yeah,
of the
secured.
case should. Yeah, so currently it is HTTP. Why do you think you need HTTPS here?
A secured connection.
Yes, okay. So one problem is these guys are running HTTP, which is insecure. HTTPS is secure. That is one thing that you're telling. Yes. Okay. Yeah, we need HTTPS. But so can somebody explain why? What's the difference between HTTP and HTTPS? Why HTTP is insecure? Why HTTPS is secure? We'll come to that. How
Because
HTTPS
S
work
is
later.
for security layer, sir.
Security
Just
layer. Okay.
is a HTTP means it's a hypertext transfer protocol. Its lack
Mm-hmm.
of security layer is lacked here. So we are going for
Mm-hmm.
HTTPS. That S stands for
Okay.
security, and we can
No.
have
ठीक है.
some
Mm-hmm.
examples also, like
Okay.
a banking app and a banking online
No,
service
when it
are
says
using.
understood. Let me take a pause again. Let me ask you again follow-up question. So when you say HTTP is not secure, HTTP is secure, can you tell me what actually happens? What will allow? Will it be able to transfer money to somebody else?
No, sir.
Or
We have that problem while transferring your money
mm-hmm.
without using a secured layer in a internet
Mm-hmm.
service.
Well, okay. 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 We'll take that. So one thing is HTTP is insecure. Okay. Let's
Yes, sir.
let's
Yes, sir.
put it that way. Okay. HTTP is insecure. Great. So that's one problem. Anything else that you find is a problem here?
Um,
Encryption and decryption.
Encryption and decryption.
Yes. So yeah, so this is exactly what happens in HTTP. HTTP is basically a plain text protocol, which means that there's no encryption, more precisely. So that is one problem. Yeah. What is telnet? Anybody? Any idea what is telnet?
Terminal emulation.
Yes. So is telnet secure, insecure? Okay.
Partly secure,
Yeah.
partly insecure.
Okay. So basically, telnet by generic secure, insecure will not go to that definition, but basically telnet works very similar to what HTTP does. It also works on plain text. That's one. Okay. So any other? So somebody in the chat they say that username password is shared. Okay. It's not about sharing. It's again, yeah, it is username password is the authentication mechanism. Anything else? Anything else that you feel, guys, can go wrong? So one, the data is not encrypted. The username password is being authenticated. Anything else that you can look into? Great. It was nice participation for everybody. Yeah, again, very nice creative questions, creative way of looking into it. So basically, every we have here, there are four aspects we're talking about. One is website runs on HTTP. HTTP basically means it's a plain text data, which means whatever the user is talking to the server, whatever the admin is talking to the server, all data happens in plain text. Now, what do you mean by plain text? Plain text means anybody who will do sniffing. Yeah. So anybody who, if they're doing any network tapping, if you remember, a couple of decades before, there was something called telephone tapping, right? People who have seen that from electronics background would have EC background would have known it. So basically, you can plug in your landline phone to that two wires on the extension, and you can yeah. So and you can literally listen what other two people are talking to each other. Okay, that in a more data tampering. Yes, you can yeah, pretty much you can capture these data. You can literally see what these are talking about. It's like overhearing. That's what happens in plain text data. Okay, so capture you can capture that data. Sorry, can you guys can you mute yourself, please? Yeah, great, thank you. So pretty much HTTP or Telnet are plain text data. So literally, if anybody is in the network, they can easily see what you're talking. They can also see what credential you're inputting. To some extent, if possible, they can also tamper data. For example, let's say you are the user of Finserv app, you are transferring money to your friend. Okay. Now, if I am in your network and if you are using HTTP traffic, then I can do certain attack. I can manipulate your traffic. And instead of you sending your money to your friend, I can reroute or I can tamper the data in such a way that I can make the money come to my account rather than going to your friend's account. Okay, that's a main problem with any kind of plain text data. So in this case, both HTTP and Telnet, both are talking in plain text data, because of which we can easily see the data, and to some extent we can also tamper it. That's on these two parts. Secondly, when it comes to username and password, today, whatever websites that we access, all online data, even offline data as well that we do, everything has username and password, but we always recommend to use this username password is insecure. Now, how it is insecure, how this can be secured, that we will discuss as we go forward. Lastly, server trusting anything inside the network. Now, the idea in general world is the moment you have firewall, you're secure. And there are also people people also think that anything that is inside the organization is secure. That is what we are trying to remove today. Okay, so there are three problems that we are trying to encounter here. One, the data is in plain text, HTTP and Telnet. Second, when a username password is being used, how this can be insecure. And lastly, how if you trust something by default, how it can be a problem for you. Okay. So far, all good, guys. Can I get some thumbs up or confirmation in the chat? Great, thank you. Thank you. So yeah, so you can use thumbs up for if you're clear with the concept. Let's go to the first case study. There's an attack called MITM. Anybody can give me the full form of this attack, please? MITM.
Man
Yes,
in middle
perfect.
attack.
Yes, perfect. So basically, an attack called man in the middle attack. Basically, it's very known as a abbreviation of MITM only. So this attack is the actual attack which is used to overhear to intercept the traffic between two people. Okay, so just like how we used to do telephone tapping in the olden days, people can literally see what two people are talking to each other. Now, this is not a vulnerability; it's a network configuration. Okay, that is why it is very hard to secure it, to secure it. That is why we recommend not to use plain text protocol. Additionally, we don't recommend people to use free public Wi-Fi or any public Wi-Fi, so that what happens in public Wi-Fi is you don't know who your fellow network guy is, and to some extent they can do a lot of things. So if you connect to any Wi-Fi which you don't know who is owning it, what data is hosting it, all those data, then pretty much there are higher chances that it can steal your data. Even if there are some extent that can happen, even if your data is traveling to HTTPS, even if data is being encrypted, then also people can do certain attacks to steal your data. Okay, so let's not go to the nitty-gritties, but one suggestion or one best practice I would recommend is if you don't know whose Wi-Fi it is, don't connect. As simple as that. Okay, this in today's world can go even to your charging station as well. Don't plug in your USB directly to a charger which is available on airports or railway station or something like that, because they can also do data transfer on a USB as well. Again, there are possibilities. Coming back to the case study here, if in this case, let's say a user, if he's part of any Wi-Fi network, public Wi-Fi network, let's say assume that this user has gone to a railway station, there is a rail wire, which is a public Wi-Fi. He kind of just connects to that and he makes a payment. Okay, what happens there is because this data is traveling on HTTP, which is plain text traffic, which is not encrypted traffic, then obviously what bank details, amount, his bank details, the two account bank details, everything can be captured by the attacker. Okay, that is one risk. Okay, one simple mistake can ruin the whole business. It can ruin a business for the company as well, and it can also be a problematic thing even for the user as well. That is what plain text about it. So yes, so we discussed about that. We should not use public Wi-Fi. This is plain text protocol. All fine. Now what do I do? How can we secure from plain text protocol attacks? Any idea, guys? How can I secure from MITM attacks? Yes, somebody have already given us answer in the last session. In the last section is use encryption. Somebody also recommended use HTTPS. So the difference between HTTP and HTTPS is that HTTP is a plain text protocol, which means the data is sent as it is. HTTPS is encrypted text protocol, which means the data is encrypted. Okay. Now you might be asking, what is encryption? Okay, let me just break it in a very simple terms. Encryption basically means you're just transforming a data into a medium or into a type where a normal person cannot access it. Now, again, you can take an example of anything. Let's say, for example, when you can go back to your college days. So within a group of your friends, if you and your close friend is talking something and you don't want your other person who is sitting next to you to understand it, we talk in a different language, isn't it? Let's say, for example, we all know Kannada. One of your friend whom you want to hide something doesn't know Hindi, but your best friend knows Hindi. So what you do is you and your best friend talk in Hindi, whereas your other person doesn't know Hindi, because for him it looks very gibberish. He doesn't understand what you're talking, but your friend understands it. This is exactly what happens in encryption. Let's say if a sender wants to send some data to recipient, he takes the data, he just encrypts it. What is encryption? He just transforms the data into another format, or technically it's not format, it into a different content altogether using something called key. Okay. He will just encrypt, he just transform this data into a ciphertext, which will look gibberish, which does not make any sense for anybody who doesn't have the right key. Only if you have right key, it will make sense to you. If you don't have the right key, it will look gibberish for you. Just like if you don't know Hindi, it looks completely, this guy is just blabbering. If you know Hindi, it makes sense for you. So Hindi, the language, is a key, whereas the content that you're talking is actually the ciphertext. Okay, is this clear for everybody? The basic understanding of encryption is clear for everybody? Any queries, questions so far? Any queries from anybody?
Sir, can you please tell one question, sir? I'm Niveta.
Yeah, please.
Can you
Please go ahead.
please tell any good algorithm for encryption? There is a lot of algorithms are there.
Yes, I'll come that in a 1 second, because encryption, it is done in real world. Encryption is done for two purposes. Okay.
Okay, sir.
One, if you're doing encryption for data transit, there's something called data transit, which means data is moving from one system to another system. If that is the case, we use different type of algorithms. In other words, if you might have seen that in BitLocker, if you're using Windows, we have something called BitLocker, and even in Android phone, we have something called disk encryption or
Okay, sir.
data at rest encryption.
Data.
We use a different encryption. For example, if you take website only, when the data is in DB, we use a different encryption.
Okay, sir.
AES, Advanced Encryption System, if not wrong. I might be wrong in terms of the abbreviation, but it's called AES. AES 256 is considered as a good algorithm for rest.
Okay, sir.
This could be your hard disk or any data at rest.
Okay, sir.
There's something called for HTTPS and all, we can use TLS. As simple as that. Okay.
Okay, sir. Okay, sir.
Great.
Thank you.
So let's go to the next. Now, Yeah, thank you. So let's go to the next aspect. So yes, so you say that, okay, when we are using data transfer between two systems, for sender, I will, so whoever has the key will have can decrypt the data. What if you're talking to the very first time? Now let's just, we both know each other because of Alba's Institute, right? So they give you a link. I had a link. They sent me a link. They sent you also the link. That is how you guys were able to join it. So the key was given by the third trusted person, right? Now, what if nobody of us, any of us doesn't know each other? What if even you don't know what is the Alvas is? How do you trust that person? That is where we come into a concept called private key encryption. Okay, sorry, my mistake. Public key infrastructure and private key encryption. Okay. Now, before going to private key encryption and public key infrastructure, let us come to a concept called symmetric and asymmetric encryption. Now, I'll not go detail into it because it's cryptography is again a vast subject in its own. So I'll just break it into two parts. We just understood encryption. So keep in my mind that there are two types of encryptions. One type of encryption is where for both encryption and decryption, you're using the same key, just like the lock we have in our house. For locking a lock, we use the same key. For unlocking a lock also, we're using the same key, right? That is symmetric encryption. Now, there is another type of encryption, which is a bit advanced and also used in very complicated cases, called as asymmetric key encryption. Now, what is asymmetric key encryption? In asymmetric key encryption, in a very simple case, for encryption, we use one type of key. For decryption, we use another type of key. It is not like a traditional locks. For locking, you use a different key. For unlocking, you use a different key. Not like real world case. Okay. For locking, we may use public key, or for encryption, we may use public key. If you're using public key for encryption, then you have to use private key for decryption, which is very common for data at transit. Okay. Even HTTP works with this core principle. Okay, about how HTTPS works in a couple of seconds, but just understand that HTTPS core principle is asymmetric key encryption, where encryption happens in a different key, decryption happens in a different key. Okay, in symmetric encryption, we use same key for both encryption and decryption. For asymmetric key encryption, we use different keys, public and private. Any queries so far, guys? Any queries from anybody so far? Yeah, great. Let's go next. So now we understood about encryption, why encryption is required. We understood about symmetric and asymmetric encryption. Now, how can you trust somebody with whom you're not interacted with? Not possible, isn't it? Is it possible? Can you trust somebody whom you have never spoke with? If you're talking to somebody, can you trust them? Yes, no?
No, sir.
No, right? Yeah. So, no, but what happens in terms of banking when you do money transfer, right? It could be phone pay, it could be net banking. All the time we are using TLS. Every time we are doing HTTPS, right? Now, how are we trusting it? How do you trust HDFC Bank or ICICI Bank with your data?
That is that secure layer of S. The showing some lock symbol visibly
Yes.
means
Mhm.
visually we are seeing that, and moreover our address is mentioned was HTTPS, so we are trusting just
Okay.
this one like
So
a
do you think every website which has HTTPS lock?
no
So
sir,
basically,
no sir, no, we have to check.
so let's say if I'm going to Google for some reason today, do you think Google, just because it had what's it called, green lock in it, is it secure?
It's a critical question, sir.
Okay, let me
No idea.
give you a simple example. I hope my screen is visible.
Oh, yes, sir.
Okay. So if I just type Facebook, Google, or let me type some login,
Okay.
and let's go to site some Pakistan site. Assume. Okay. So all these websites are Pakistan sites.
Okay.
Okay. So can you trust this website just because it has a lock in it? See, it has green lock. Connection is secure. Can you trust this website?
No, sir.
Uh, but yeah, so there's also re-registration for some reason it is there. But yeah, it's not possible,
Yeah.
right? So
Yes, sir.
why it is not possible? What is the reason behind it? Let us understand before going why we should not trust, why we should trust and all. Let us understand how this actually happens. How does this HTTPS or SSH or whatever secure protocols that we have, how does it work? Let us see that. This entire magic happens because of something called PKI or public key infrastructure. It is called as private key encryption that we will see as well. So what this public key infrastructure is. Now let me take one step behind you. Okay. Now let me take a very simple example. Let's say if I'm a student. Okay, I have studied for 16 years of my life, and I go to a college. I go to work. They also do my interview, but before they provide me a job, before they offer me a job, how can that company validate whether I have really am capable of doing a job, whether I have all the knowledge? How can I prove that I have studied for 16 years? How can I prove that?
Our
Your
Certification.
master's degree
certificate, our
certificate.
knowledge. Sorry,
Yes,
please carry on.
yes, certificate. Now, assume that, okay, let's assume that I'm doing a certificate in VTU. Let's say assume that the company that I'm working is in UK. Okay, how can a company UK trust the certificate? Trust my certificate? How can they validate it?
Any specific seals or
Okay,
and
Authorization.
and our knowledge, sir, by asking questions how capable or
knowledge is can be a subjective matter, frankly speaking, because without I mean, there are cases where uh, non from a person
Authority.
can have a knowledge, but he may not have a certification also. Yes.
okay.
Digital
Exactly.
verification.
The question is the answer I was looking was yes, exactly, verification. So basically, even if the company is in UK, he can trust or he can validate whether the certificate is valid or invalid based on something called a VTUs. Yes, authorization, certificate validation. So the certificate, yeah, the certificate that I have, my degree certificate that I have, so I can validate a certificate with VTU because VTU is the one who gave me the certificate. Now, this company, which I'm interviewed for, which I'm planning for a job, this company can ask you saying that is your certificate valid or not? Okay. Now, VTU then will answer, okay, yes, this certificate is valid or invalid. He will answer the company whether it is invalid or not. For that, the UK company has to trust VTU. And a company from a different country trusts VTU because VTU is being named as a certification authority. The government of India, through AICTE, has given the power to VTU to issue certificates. Is it not? That is how it is giving certificate for everybody. So far clear for everybody? So far clear for everybody?
Yes, sir.
Any doubts so far? Yeah, great. Now, the same concept works in terms of any architecture called public key infrastructure. Here also, we have something called certificate authority. So something called certificate authority. This certificate authority is the one who will be giving you the certificate. Now he will before. I mean, obviously, he does not give certificate just like that, just like VTU. It will not give you certificate just like that, right? You have to pass your exam. They will validate your practical skills. They will validate your theoretical understanding, viva, everything, isn't it? So there's something called certificate authority. who will validate your data. So when we went to google.com, so whichever is the certification authority for Google, whether it is Google itself or some other entity, they will validate whether Google is really Google or something else or some other website that we are accessing. That website will validate whether the domain name is correct, whether they have purchased a domain by themselves, who is the owner of this domain. All this data they will take. They will create 2 pairs of key. They will create, the certification authority will give a certificate. Okay, the certificate will be attached to a website. So let me take an example of Google again. If we go back to Google, okay, when you go to Google or any website, go to any website that you like. I hope my screen is visible, guys. Yeah. So if you go to the connection is secure, it asks you something called certificate is valid. Okay, any website that has green icon on it, just click on the certificate is valid. This is the actual certificate. Okay, the certificate will consist of what is certificate name, what is the organization of it, who is the one who gives the certificate. This certificate is given by Google by themselves. Okay, because Google is an entity. Similarly, if I go to some other website, let me go to AICTE website. It's actually a trusted body, right? And obviously, it is also a HTTPS website. Now, if you go to AICTE website, this certificate is also given by somebody. Go to here, go here. So who gives the certificate? This certificate is given by GoDaddy. Now, because my browser, Google Chrome, is trusting GoDaddy, it is thinking or it is confirming that this website is secure. Because why? Because GoDaddy is a certification authority. You can see that there, certification authority. I trust the certification authority. So the certification authority trusts this website. So he gives me the seal that he gives me an assurance that this website is, the communication between this website and your system is secure. So far clear? So far clear for everybody?
Yes, sir.
Great. Let's go back. Okay. Let's understand how does it work. So basically, in a simple nutshell, I'll just understand, explain the process. So basically, what happens? This GIF will explain you the proper process. So what happens when, if I'm, let's take an example of FinServe only. If a FinServe wants to have HTTPS with them, what should FinServe do? FinServe should contact some certification authority. It could be GoDaddy, TrustVerify, Google, AWS, or whatever certification authority. He will have to contact certification authority saying that this is my website and these are my details. Give me a certificate, SSL certificate or TLS certificate. Okay, so that guy, let's assume that I'm going to Google. So Google will give me a certificate. So I will paste the certificate on my website. So whoever interacts, so whenever you make your system is talking with FinServe server, it will get to know the certificate. After that, it validates. Your browser will talk to the certification authority to validate whether the certificate is valid or not, whether the certificate is trustable or not. Then, after getting confirmation that yes, the certificate is trustable, so these two people, who the web server and your browser, will talk to each other. They will exchange their public key and private key. After that, they will carry out the encryption, and after that only your actual data transfer is done. Now, again, to explain your detailed TLS, it will take another 30 minutes. I can take another 30 minutes explaining you about the whole SL certificate, what happens in what is a handshake, what is a certificate validation, what is OpenSSL, all those aspects. But because of time constraint, let me summarize it in a very simple shell. So a website, whenever a web server wants to talk in HTTPS or any encryption protocol, so what they do, they go to a certification authority, they give their details, and from certification authority, they take a certificate. The certificate itself will have the public key of that particular web server. Okay, remember I said that in asymmetric key encryption, your encryption happens in public key, decryption happens in private key, isn't it? Similarly, so here, once I know what is the public key of the web server, I will generate a small secret. I will generate a small secret, and I will encrypt the secret in the server's public key, and I will send it to a server. Server will agree, okay, for our conversation, let us use the secret. And now, since the secret was also sent in encryption, and since our data is encrypted in the secret as a key by themselves, the communication between you or the web server and your client or the user like you and the web server, both will happen in HTTPS or encrypted data. Okay. So I hope you got some gist of how TLS works or HTTPS works. Any doubt on this, guys? Any queries on this? Okay. Was it too clear, or was it just bounced over everybody's head? Okay. Okay. I'll just summarize it. Yeah, I'll just summarize it. So when a web server, website more precisely, when a website wants to talk to you, the user on HTTPS, what web server will do before they be on live itself, they will get a server certificate from certification authority. When you browse that website, your browser, this all happens in the background. You don't even get to know how it all works. Right? Your browser that you're using or your app that you're using, this will talk to the website in the backend. They will exchange a certificate only if the browser or your app, mobile app, trust that certificate. After that, they will exchange a small secret. They will exchange a key, and based on the exchanged key, they will do the encryption, which means that whatever data that you are sending or your browser is sending to the server, that data will be encrypted and sent. And whatever data that the website is sending to your browser, that data will also be encrypted and sent. Therefore, any person who is doing MITM, irrespective of certain cases of Wi-Fi or public or something like that, third person should not be able to see the exchanged data. That is how your HTTPS works. Okay. Any queries so far?
No, sir.
Any queries so far? Great. Thank you. So basically, you might have heard me telling about, I use a word SSL, I use a word TLS, I use a word HTTPS. So basically, SSL stands for Secure Socket Layer, which is nothing but a protocol name. Now, Secure Socket Layer has multiple versions. So the current version or the latest version of SSL again is nothing but TLS, Transport Layer Security. Earlier it was called SSL, and later on they got renamed to ATALS, Transport Layer Security. This is the protocol name, and this is the protocol which is used in the backend of HTTPS. So the S in your HTTPS is definitely called as secure only. But the secure to work, you should have your TLS. Is now what is SSL? What is TLS? What is the actual meaning of S? Is that clear for everybody? Yes. So yes, sir. So what happens is the first request, whatever the first request your client or a browser sends to the server, that will be plain text only. It will not be encrypted. So after verifying, after the client verifies the certificate of the server, website, so it will encrypt. The client only will encrypt the request using the server's public key. Okay. So what will happen is, assume that your recipient is a website. Sender will get the public key of the recipient through the certificate. Okay, first time the sender will ask the recipient for certificate. The certificate in return contains the public key. Okay, sender will encrypt. Sorry, my mistake. So sender will encrypt is a secret in this public key only. Now, because it was encrypted with the help of recipient's public key, only he can decrypt it. Nobody else can decrypt it. Okay, that is why it will become secure here. So first time, sender will generate a secret. He will encrypt it with the help of servers or websites public key and send it to a recipient. Now, because it was encrypted using the recipient public key, nobody can decrypt it. Only he can decrypt it. Did that clarify your query, sir? Okay. Meanwhile, so far, any queries from anybody, guys, regarding HTTPS or PKA? So, yeah, please go ahead.
Sir, one doubt. Can you please help me in any real-time certificate authority? Can you quote some example for real-time certificate authority?
Yeah, so no. So Google, if you, I mean, you can literally go to any website and find out
Okay.
what is the certification authority. All you have to do is you have to go to that lock icon,
Okay.
certificate secure, certificate.
Okay.
So in every certificate, there's something called issued by. Every certificate
Okay.
will have something called issued by. So
Okay,
issued by
sir.
is nothing but the certification authority. For Google,
Okay.
it is Google themselves. For AICTE, it is GoDaddy.
Okay, sir. Okay, sir. Thank
Okay.
you, sir.
Similarly,
Thank you.
whatever website you want, you can verify it. Okay, great.
Okay.
Okay. Now you might be asking that. Okay, yes, Bharat, we discussed about SSL, we discussed about HTTPS, what we discussed about TLS. Now, what is the meaning of public key infrastructure? Now, the meaning of public key infrastructure is all about these whole landscape. The concept of certification authority, the concept of keys, the concept of HTTPS, the broader concept of these asymmetric encryption or private public key encryption is what we call as public key infrastructure. That is where your certificate authority, all thing comes up. So on the title, you will, on the broadest aspect, you will have public key infrastructure. Inside that, one of the protocol is TLS. Similarly, we will have something called SSH. SSH is a secured version of Telnet, which is also called as secured shell. It works very similar to how Telnet works. Only difference is Telnet is plain text protocol, SSH is encrypted text protocol. That's the only difference, nothing else. Okay, so that's the case. So now I hope so far it is clear for everybody. Now from FinServe, let's go back to the case study. Now what happened? FinServe, we observed that in FinServe the data was running with HTTP. So we have asked the FinServe team to run it on HTTPS, and the admin traffic was running on Telnet. We've asked them to use SSH. Now, do you guys think this company is secure now? Is this security enough now? Yes, no?
I think no, sir.
Okay, great. Yeah, this is exactly what I explained a couple of minutes earlier. Just because you have the green lock on any website, it doesn't mean it is secure. Right? Again, just take it as a personal understanding. Not all websites that we see are secure. Okay, so just because they have green flag in it, it is not secure because there are a lot of other aspects. HTTPS is just one piece of your car. Just if you're in your entire car, if just your wheels are good, is your car safe to drive? No, right?
No.
You need
No.
all other aspects. You need seat belt. You need a lot of other things. Just like that. Consider HTTPS as just that one. Now, what else is wrong? What else can go wrong? Yeah,
Sir,
I think I accidentally.
algorithm,
Yeah, go ahead.
it can.
Yeah, algorithm is again, yeah. So, exactly. So going to the aspect of certificates or encryption, yes, your algorithms can be a problem. Let's say the reason why I explained to you about SSL and TLS, the reason why SSL older versions are not secure, we say that if you find SSL certificate or SSL protocol, when your website is using SSL protocol version 1 or 1.2, SSL version 1 and 1.2 are considered insecure because their algorithms are not good. They're not sufficiently encrypting the data in a random way, right? So that is why we recommend to use TLS 1.2 or 1.1 or 1.2 or 1.3 if it comes in later. Those protocols are considered as a secure protocols. Okay. Great. Now let's go to the another sector of security. Okay. So how do you guys log in to any website?
Passwords.
How do you guys log into any website? Yeah. So we all log in with passwords? Yes or no?
Yes, sir. And some security pins additional to one OTP. You
Now,
can
why do you
put.
want this additional pins? Why do you want this OTP? What happens if you don't have OTP?
We can't log in. It's a one additional step for secured login. So if
Yes. Now I'm saying, what is the need of this secure login? Why do we need this additional pin?
um
Okay, I don't use the reason why. So what happens? Let's assume that we don't have a pin. That's what our yes, exactly. So that is what we will be discussing here. So that is what exactly is. So the additional pin that we're talking about is called as multi-factor authentication. Now, what is
yes,
multi-factor authentication? That we will see in a couple of seconds. But why it is needed? Now, let's say you have 10 different websites. Okay, you have account in 10 different websites. You create a website, you create an account in website called ABC. You create a website in account CDF, and so on. Right? Let's assume that your account in abc.com got compromised, or not your account, the entire website of abc.com got compromised. Is your password visible for hackers? Yes or no? Will the hackers get your password?
yes, sir.
Definitely, right? Now, can't those hackers log into other websites? Because it has a human tendency. For all the 10 websites, we are using the same password only, isn't it?
Yes, sir. Yes, sir.
Right. So this is exactly why we need multi-factor authentication, just to ensure that even if a attacker knows your password, he should not be able to log in. Now, is that the only threat? No, because passwords in real world, there are multiple type of password attacks. There's something called social engineering attack. People will trick you to give the passwords, just like the way scamsters do. They will trick you to give the OTP, isn't it? Similar to that, they can trick you to give the passwords. There's something called credential stuffing. Now, what is credential stuffing? So they will get the leaked credentials, whatever leaked credentials that we have. Let's say there are multiple websites that says if your password is compromised or not. There's a website called haveibeenpawned.com. There's another website called password leak, and so on. So those websites will give you the compromised passwords. There I can get the compromised passwords and I can try to hack. Something called keyloggers, a small software that is sitting on your laptop, and whatever you type, it will capture it. So that also hackers steal your passwords. There's something called dictionary attack, or brute force, in other words. They will try different combinations, different as a passwords. And lastly, something called password spraying, where people try default passwords, like admin. Okay, a lot of times in our labs, in our college labs, in other institution labs, the password is same, right? We will be using default password, admin, or the lab name, DB lab at 123, or some other institution name with some random number. So there are default passwords. So people use password spraying. The attack is called password spraying in more precise. Now, how can we prevent from this? The best remediation for this is something called multi-factor authentication. Okay. Now, what is the meaning of multi-factor authentication? There is a shortcut to remember this. Something called something you have, something you know, and something you are. So this is what we generally follow in the industry. Something called something you have is nothing but your mobile phone, your ATM card, or your smart cards, or YubiKey. So that's something you have in your possession. First factor of authentication is something you have in your hand, something that you can hold it. Second is something you know, something you remember. Passwords, the PIN, security questions, this all will fall under something you know. And lastly, we have something called something you are, which is your fingerprint, your iris scan, and other biometrics, because it's very unique. Only you have that fingerprint. Only you have that iris pattern. Okay. Now you guys tell me, there's a recommendation in every security framework or certification everywhere that we always recommend to have at least two type of authentication together. Should have a combination of something you have and something you know, or you might have a combination of something you have and are and so on. And can you tell me what is the in what section does your username password come in picture? Does it come in possession, knowledge, or being? Where does your username password come into picture? Possession, knowledge.
Knowledge.
What
Yes,
I have.
great. Yeah, what do you know? A password is something that we remember.
Yeah.
Yeah, pin. Yeah, pin is something that you know. So that is why we use something you know. Now, you guys in most of the colleges, you might have that fingerprint scanners, which will mark your attendance. Where does that belong to?
The biometric that being.
Yes,
Person
exactly.
being.
Yes, something you are, your being. Yes. Yeah. So OTPs that you get on a phone, what is it called? Is it knowledge,
What I have.
being, possession?
What I have.
Yes. What you have, something you have. Yeah, possession, right? But still, yes. So that is why when you do a bank transactions on your mobile phone or anywhere, that is why you get an OTP. Because according to a bank, what it does, to log into the bank, you are using your username password, which is something you know, that is knowledge. And once they're sending the OTP, where are they sending the OTP? They're sending the OTP to your mobile phone that is under your possession. Okay, that is why most of the critical transaction happens through possession and knowledge. Clear? So far clear for everybody? Why do we need MFA?
Clear.
Right. Now, but does this mean that a password should be insecure? Can we set anything in password? Can I just put password as my password just because I have multi-factor authentication?
No.
Yes. So passwords should also be secure. Now, what is the etiquettes of passwords? There are multiple case studies or multiple frameworks that explains how your password should be. So this just keep it a simple aspect. Okay. Just keep your passwords as your toothbrush. There's a one analogy for it. Okay. So the dentists say that at least you should change your toothbrush at least twice or thrice a year. Basically, it is 4 times a year, every quarter. So every 90 days or 60 days, every 90 days, you have to change your toothbrush. So similar way, change your passwords the same way how you change your toothbrush. So next time when you go for brushing, just think that is your password. Okay. So I hope everybody change the brushes after 90 days. Okay. So first thing is change the password regularly. Second thing, don't share your passwords. Okay. There's also another analogy say that keep your passwords like your inner ways. Don't share it. So just like that. That's the analogy that I use. And also make sure that passwords are hard to guess. The passwords should always be hard to guess. Stop using known passwords. There was also one example that in a session where I was just listening into it, that we were mentioning that people generally use their first name, their kid's name, their spouse name, their pet name, all those names they usually keep it as passwords. Okay, so always I have this implemented in my case that my passwords 90% of the time the word that is used in password is nowhere related to me. Okay, keep that mechanism. So the password that you're using, the words that are used in passwords, make sure that those words does not relate to you. Okay, which is very hard to identify as well. And second thing, there's something called passphrase. Okay, passphrase. So usually what we do with passwords, we just give a word for it, isn't it? We just give a word in the password. So instead of giving a word, keep a sentence. Okay. So there are ways people use this is my secure passwords. That's a word. So attacks like dictionary attack or password spraying will not work over there. Okay. So got some idea, guys? How can you store passwords? How can you keep your passwords secure? Any queries in this?
Based on the centralized.
Yeah. Somebody was asking some query. Can you come in, please, sir? Okay. That's right. No problem. So yeah, let's go next. So whatever we discussed right now is at the user end, like how we can configure, how can we keep our password secure. But what happens in system? How can we ensure when we are building a system, where as a company, when you're building technologies, how can I secure passwords in a technological way? Okay, there are multiple ways of doing it. So usually there are various authentication protocol. Okay, just let me clarify you. Basically, there's two concepts when it comes to verify or logging in. Something called authentication. Authentication basically means I'm validating, I'm verifying that this user is that guy. Like I have to verify I am Bharat. How can I verify? With my various key. I have my Aadhaar card, I have my voter ID, I have my passport, all those expressly. Something called authorization. Authorization is nothing but permission that you are giving a user or an entity to do a task. Okay, so that is authorization. Authentication, remember always, is to verify whether this person is really a person or not. Authorization is to verify whether this guy has right permissions to do whatever he wants. Like for example, in our case, all of us have logged into Teams, right, to join this session. So Teams is validating whether we have this, whether we are a user or a bot or not. Secondly, the backend team, the organizing team is validating based on our names whether we have a right to be in the session or not, right? Because we don't want anybody else who is not a part of this AICTE FDP session to log in, is it not? That is permission. Whether I have a right permissions to log in or not. That is authorization. Now there are, from a technological standpoint, there are multiple protocols to do that. There's something called OAuth. Now, again, one disclaimer for you guys. So I have tried to use extensively the AI for various reasons, for clarity and to support all those things. There might be a lot of spelling mistakes because it's AI generated images. Most of them these are. So please don't go with that spellings. A lot of spelling issues, typos is in the images. So please bear with that. So the OAuth spelling here is OAUTH. So with a small spelling mistake over here. So OAuth is a protocol that is used for authorization. So remember, whenever we use sign up with Google or sign up with or create a profile with so and so social login, create a profile with Google, create a profile with some other website, right? Or create a profile with GitHub. Don't confuse this with logging in or sign in with Google, sign in with GitHub. But sign up is different. Sign up is you're creating a profile. So when you create a profile using Google, what happens is, let's assume that you're creating let's say example of Instagram, right? When you're creating a Instagram account, there's an option with Instagram that you can create an Instagram account with Facebook. So what happens there? So when you say sign up with Facebook, Instagram will send a request to Facebook and get data from Facebook, and it will copy that data inside Instagram. That is copying. OAuth is copying. Okay, it will copy. It will not authenticate. It will copy the data from Facebook to Instagram and create a profile. Sign in with Facebook is different. That we will see in next slide. Okay. So OAuth is a protocol that is used to authentically get your data transfer. Similarly, there's something called OpenID Connect, which is also a protocol which is used for authentication. Okay. OpenID is a protocol for authentication. Similarly, there's another protocol called SAML. Okay. Secure assertive markup language, if I'm not wrong. So this is again a protocol that is used in the backend to connect multiple connections. For example, let's say if you log into Google, you can, with the same account, you can log in to YouTube, you can log into Gmail, you can log into Google Drive, right? So the backend protocol which is supporting this is nothing but SAML. Okay. Lastly, there's something called JWT token. So people who have done some development or you're part of any Java coding or any web development, you might have used something called cookies, which is used for authentication. Again, it's a medium to store your temporary tokens, right? So JWT is another token, JSON Web Tokens. It is the mechanism to store your tokens in a temporary case. Okay, so OAuth is a part of authentication protocol, but the actual function it does is to do authorization, to transfer data with permissions. OpenID Connect is another protocol which will validate authentication, check a user whether is the same user or not. SAML is used as another authentication protocol to authenticate user into multiple websites. Lastly, JWT token is basically a token. It's the actual token which will contain your authentication informations. Okay. So far clear, everybody? Any queries with respect to these 4 protocols? OAuth, OpenID Connect, SAML, and JWT token? Okay. Now again, yeah. Please go ahead.
The JWT protocol is for authorization or authentication, sir?
It's actually a technology to store your tokens, man. It's a type of token, actually. It's a type of token.
Okay. Thank you.
Great. Now, again, giving the same example here, there's also something called social login and single sign-on. Okay. The social login is nothing but sign in with so-and-so. You can sign if you're signing with Amazon, if you're signing with Apple, if you're signing with Facebook and so on, right? You don't need to create an account. If you're having a Facebook, the website is trusting you on Facebook's validation and do it. Okay, for example, if I'm creating a FinServ, I don't want to maintain the users because of a lot of regulations. There is GDPR regulation. There is recently there is DPDP regulations and all those things, right? Because of regulation, I don't want to maintain users. Instead of creating users in my system, I will rely on third party. Okay, that's what social logins is. Similarly, there's something called single sign-on, which is the same concept of Google. You log into Google. In Google, the same account with the same login, you can access YouTube, you can access Gmail, Drive. Now, the technology behind or the protocol behind these single sign-on is SAML, is a technology. Single sign-on is a concept. Okay, don't be confused with SAML and single sign-on. Single sign-on is a concept. The protocol behind a single sign-on is SAML. Okay. So far clear, everybody? Any queries? Great. Now let's get back to our case study. Now, okay. So now we have the website is running in HTTPS. The traffic is also running in SSH, which is encrypted protocol. We have implemented MFA, which means user before login, he will have to type in a username password, and also he has to be giving the PIN, multi-factor authentication, and only then he'll be login. Now, is this secure? Is this secure enough?
No, sir. Can be compromised.
Yes. Why it can be compromised? That we'll see here. Okay. Why? Because the server trusts anything inside the network, which means if an attacker compromises one of the server, okay, let's assume that this firewall had a vulnerability, a loophole, okay, or a server had some loophole. If I just compromise one server, I can take the entire landscape. It's like just placing a bomb in one of the room, and because I have placed a bomb in one of the room, entire building can be collapsed. It is same as that. Okay, that is why it is not recommended to trust anything that is coming from inside. So basically, it is not recommended to trust anything. Okay, why? Let's tell you. Let's say there are multiple systems. If I compromise one host, I can use later on what we call it as pivoting. So with the help of pivoting, I can start talking with other systems, other internal systems, and capture data and send that to your attack infrastructure. Now, because I have compromised the host, even if I have a firewall, even if I have any technological defensive tools, this will not block me. Because why? Because I have compromised the server, and the server is sending the data outwards. Okay, it's an insider attack. Because one of the internal machine is got compromised. That is why I can easily bypass that firewall and so on. How can I secure it? Very simple. There's a concept called zero trust architecture. So instead of blind, observe here, we are blindly trusting remote server, and remote server is able to talk to internal servers as well as backend API as well as database, which contains your very informational data, very critical data, right? So instead of that, we are saying that don't trust it. It is zero trust, which means that anybody, irrespective of whether the data is coming from internal system or if it's coming from internet or it is coming from anywhere, irrespective of wherever the data is coming from, the data should be validated. The authentication should happen, authorization should happen, which means first have to check whether this user or whether this request coming from a so-and-so computer is trustable or not. That is authentication. Later, have to verify whether this data which I'm getting, whether this permission, whether this request I'm getting, whether this guy has right permission to do or not, right permission to perform the activity or not. That also we have to do. So zero trust architecture, the base concept is trust, don't trust anybody, verify each and every aspect, which means that let's say if a user is saying to access a request, it will verify, it will check whether this user has access or not. Only then it will give you the access. Example, this is a very simple example. What is happening here is basically whenever any request is made, the request is sent to a engine inside zero trust architecture. This engine will validate whether this user is given permission or not, whether this user is a valid user or not, and post that he will allow you the data. Okay, irrespective of this, whether this user is coming from inside the computer, inside the network, or outside the network. In either case, he will validate it. Only then he will give you the access. Got an idea of zero trust, guys? Any queries on zero trust? Basic understanding? Again, all these topics that we are discussing today are very deep subjects. So I'm just scratching a surface of that based on our understanding. Okay. Any queries so far? Great. Okay, let's go back now. Going back to our case. So earlier, what was happening? What was our state when we started this scenario? When we started, the website or this FinServ app was running on HTTP. So because HTTP is a plain text protocol, any person who with a network access will be able to access my data. Hence, we recommended to move them from HTTP to HTTPS. Similarly, the user, the backend admin, was also using Telnet, which is also insecure protocol. We asked them to use SSH, which is again encrypted text protocol. Secondly, the user, whoever was using FinServ, were logging in with just username and password, which if password is compromised, that means user can easily log in. That's why we recommended them to use MFA, and because of that, they have implemented now. So whenever a user wants to log in, he will log in with username, password, and also he will have to provide a OTP for it. Lastly, by default, all the requests were trusted in the previous architecture. Now we have implemented zero trust network. You can see that each thing is created as a block. This is a different block. This is a different block. This is incidentally, this is a different block, and this is a different block. So each element will be considered as a different blocks. So every a data request from one block to another block, it will be authenticated. Consider this: every time you go to a different system, you will again be asked username, password. Again, you have to enter the PIN, and after that, again they will validate whether you have permissions to access this or not. Only after thorough examining, you will be examined. So this is something like going into a military setup. Every time you pass some region, okay, zone, every time you pass a zone, you'll be again verified with a proper thorough checking. Okay. Now, before we go to the third part, do you guys think this is secure enough? I leave it to you. Do you guys think this is secure enough? You have implemented a lot of stuff here. What do you think? Is this secure enough?
Still, it can be compromised, sir.
Yes. Security is not only a tool or a mechanism, so it's a whole architecture. So this is as similar to building a dam. You can build a pretty big dam with all the latest technology, everything, seal everything and all. But if you find for you to build the entire dam securely, you have to build the end-to-end dam architecture securely. But for an intruder to break a dam, all he needs is one small loophole, right?
Yes.
That is why security is an architecture, it is not just a tool. Okay. With that, I hope the base concepts are clear. So we have another 5 minutes. So please raise your questions. Any questions that you have regarding any of the security topics or any of these three topics that we have discussed, PKI or security protocols, authentication protocols, and zero trust architecture, sorry. So within this, any questions if you have, or any questions in generic if you have in terms of cybersecurity, you can ask right now. The next session will be a continuation of this. We discussed, right? So how it can be compromised? Somebody said, right, it can still be compromised. What are the different avenues it can be compromised and how that can be secured? That we will see in next session, which would be another interesting session. But before that, we'll take just 5 minutes for any questions. Any questions from anybody, please? It's the time to ask. Any questions from anybody?
Hello, sir.
Hello, sir.
Yes, sir. Please go ahead. Please go ahead, sir.
Sir, you said like while accessing HTTPS server,
Mhm.
we are using two keys. That is
Yes.
public key and private key. Is it possible to access with a single key also?
It's okay. When you say access, you mean data transfer, right? You're talking with this website. Is that right?
Yes, sir. Yes, sir.
Okay. So, yeah. So basically, what happens? That's why I said HTTPS is a subject by itself. So what happens in HTTPS is, if we observe, we are saying that shared secret. Okay, something called server's public key. So what happens generally is the initial conversation. So let's say, for example, we both are talking to each other, right? First time when we talk to each other, we greet ourselves, right? We say, hi, sir, how are you? Hello, and all those things. That is in technical what we call it as handshake. Okay, for the first time we are talking to each other. Until the first time, we don't know each other, isn't it? So that time I'll be using public key and private key for encryption. I will use your public key and encrypt data and I'll be sending, which means I'm using two keys for encryption. Once our initial conversation is done, the first 5 minutes, our first handshake is done, then we will use a common one key. Instead of using two keys, we will be using one key for the communication, which is generally called as hybrid key encryption, which is what we use in TLS. So let me again clarify, sir. So what happens in HTTPS by default, first initial conversation will happen with the help of two keys, public key and private key, which is obviously required. After that, I will share you a secret, which is nothing but a key again. After that, it will only happen with the single key only. Okay, first communication, two keys. After that, second onwards, the actual data transfer will happen in single key.
Sir, I have one more doubt. Like if I
Yeah, please.
frequently use same website, then same process will take place, or
Okay, there are two ways. There's something called timeout that happens. So again, which can be enforced, which cannot be enforced. There are cases. Again, it depends on the website configuration. You can and you can make that throughout your entire duration. Let's say if I'm using the website for 5 hours, let's assume that I'm watching Netflix for 5 hours. So that time I can enforce that for the period of 5 hours. There should not be new authentication, new certificate, or new revalidation should not happen. That I can enforce for Netflix. Similarly, if I'm using a banking website, which is more critical, there I can enforce. I can enforce what is it called, deauth, where I'm disconnecting the connection for let's say 15 minutes. So every 15 minutes, the user will have to again initiate this HTTPS handshake or TLS handshake, and they have to follow. That is also that we can do, sir.
okay, sir. Thank you.
Thank you. Any other queries from anybody? We have another 1 minute.
So to what extent students' projects can be taken up in this type of domain?
Okay, you're talking about final project, ma'am? Final year
Yes, sir.
project
Maybe
or
mini or final year projects. Yeah,
okay.
final year projects,
Yeah.
right? Because certifications, everything is involved.
Yeah, yeah. So
Or
basically,
how
ma'am,
it can be simulated.
yeah,
Yeah.
PKI or public key infrastructure. There are two major concepts in PKI. One is this TLS, which is used for data transit encryption. So there are a lot of algorithms that we use in today's world. There's a big list of algorithms that we use. There is something called elliptical algorithm, Diffie-Hellman algorithm, to go deeper. So all these algorithms will have some loopholes. Like you might be hearing people saying that once quantum computing comes, all the algorithms will be vain. Okay, because the cracking can happen very fast. So all the keys will be decrypted. So all this saying that people are saying because every algorithm will have some limitation. Okay, we say that RSA is more secure in today's world. RSA 256 algorithm is considered as a secure algorithm for any data transit communication. Now, with the help of quantum computing, I can break it. Now, how can I break it with the help of quantum computing? No, it doesn't say, or any encryption algorithm doesn't say it is unbreakable. It only says you need time to break it. Okay, there's a comparison saying that if I keep my password 4-digit password, it will take me 10 minutes for cracking password. If I keep 16 minutes, 16 character password, it will take me 22 years to crack the password. So it doesn't mean my password cannot be crackable. No, the password can be cracked. It's only a matter of time. Same thing happens in terms of protocol. Every protocol can be cracked for some using some loophole, some time making or all. So for student projects, they can work on these protocols. They can work on improvising these protocols. They can take example of this PKI. Inside that, you can take TLS protocols. You can take there's something called digital signature, which comes in private key to public key encryption aspects. So they can work on that algorithms as well, which is very good concepts if they're going deeper. They can also go with zero trust. How can you implement zero trust in an automation? Because zero trust is there in industry from almost like 4-5 years. Even today, there are a lot of new inventions, new innovation that is happening with the help of zero trust. They can do attacks. They can do projects on that as well. They can do projects on MFAs, different aspects. Because generally in the industry, we say OTP is not a secure way of doing MFA. If you go deeper into security, people say SMS OTPs, the OTPs that are sent on SMS is not secure. Why? Because there is a very famous attack vector called SS7, Signal System 7, which is a loophole in towers, which can be misused. Or if your phone is compromised, SMS also can be compromised, right? So all these problem statement in the industry can be taken as final year or mini projects, and we can work on it. Hope that answered your question, man. I hope.
May I ask you? So,
Yeah, ma'am. Go ahead.
is an
Sorry, my voice is
nowadays the
very poor.
evolution of quantum computing and blockchain techniques, whether it can create an impact in PKI, sir?
Definitely, ma'am. There's definitely possibility. There are higher chances because the root cause of the cryptography. The cryptography is nothing but math, right?
Oh,
And quantum
yes,
computing is nothing but a calculation at a higher speeds. Okay.
yes,
So what is blocking a hacker from cracking the algorithm is nothing but the limitation on math, which can be attained by quantum computing. So the traditional encryption algorithms that we have, as I was giving example of RSA and a couple of other things, so these will definitely be a problematic in future. Again, there's a counter argument for this, but still there because of this, there are a lot of other algorithms that have quantum resistance in it. Okay, so there are a lot of white papers or IEEE papers where people have gave the proof of concept of how certain algorithms that is available in today's world also can be quantum resistant, which means that even if we have quantum computers, those algorithms, which is not uh, those new algorithms can be resistant to quantum computing. But these algorithms are not AES or not RSA, which is used in our TLS or data encryption, BitLocker. These are not that. These are more sophisticated algorithms.
okay,
Okay.
sir. Okay, sir. Thank you,
Great.
sir.
I think we exhausted. Yeah, I think we exhausted in another 5 minutes. But yeah, again, the thing I've shared on the screen is my profile in LinkedIn and my email ID. You can also still reach out to the queries and connect for anything else and in my LinkedIn profile and email. Yeah. So before we continue, I think I have one question. Manjunath sir or anybody from the organizing team, can we
Huh.
continue with the next session?
Yeah,
How is
you
it, sir?
can continue, sir. Suppose if you want to take some 5 minutes break, if you can take it, sir. Yeah.
I'm okay, sir, but for
Oh,
the
you are okay,
audience,
no? Okay. Then you
yeah,
can continue,
I'm
sir.
okay.
No issues.
Okay, great.
Okay, sir.
I
You
think
can
most of
continue.
yeah, I think most of the faculties usually have a tendency of taking sessions for more than 3-4 hours continuously.
Yeah,
So
yeah, yeah.
I hope that should be fine. Great.
Yes, sir.
Yeah,
Yes,
great.
sir. You can
We'll
continue.
start, sir.
Yeah,
Second
good.
session.
Yes,
Yeah.
sir. Good. Yeah.
Thank you, sir. I hope everybody's fine with that. It's not like uh, brain drain part. So let's continue. I hope my new screen session on networking protocols is that visible for everybody?
Yes, sir. Visible. Yeah.
Thank you, sir. Great. So what we discussed a second before. So I was trying to. Okay. There's one request for break. Okay, let's have a 5 minutes break. 10 minutes will be too long. Uh,
Okay, okay.
let's
5 minutes.
let's
5 minutes you
let's
can give, sir.
have a
Okay,
5 minute
okay.
break.
Fine. Thank you.
Okay. I just put it as 5 minute timer.
Yes, sir. That is good.
So let's use it. Let's use this. Okay. So after this 5 minutes, we'll be back. Okay.
Yes.
Starting. Some reason it's not starting. Okay. Okay. Start.
Meeting orders. Phone
Hi guys. Hope I'm audible.
Yes, sir. Yeah.
Great. Yeah, great. So I just read that chat right now for sharing the LinkedIn profile. I'll share it again by the end of the session again. It will be the last of the session. Anyway. Great. So let's start. Great. So in the previous session, a couple of minutes before, we were discussing about a couple of cases that we discussed about how we can use the PKI, public key infrastructure, HTTPS protocol, zero trust, in order to secure our environment, right? So that gave us a pretty much a good idea about how do we get these information, how can you secure ourselves. Now, I would say this sessions is going to give you a couple more technologies, bit more fundamental than the previous case, because whatever we saw earlier, when you look at from a OSI layer or a network layers, they are the most top layers if you as a user, right? When you go these technology, these are more fundamentals. So let us understand this. Let's go forward. Again, let's continue forward. Let's take the same case study or same example. Now in FinServe, right now we are here. Okay, right now we are at a FinServe payment app. Now this app is right now working working in HTTPS. The user to server communication happens in SSH. There is a zero trust network through which your communication is secure enough and the validation is happening and everything. Irrespective of that, there are still a lot of problems. There is no traffic inspection is happening. There's no way to validate if the data is coming there or not. That means is still accessible to public internet. Flat networks are there. There are still open ports. Now, can you guys tell me, very simple question. Does the security controls that we implemented earlier, it could be zero trust, it could be authentication with the help of MFA, are these just enough? Or let us go ask more fundamental question. Does the security, where does the security fail first? Is it failing at the code or does it fail at the network?
Sir, I
I'll
think
pause
it's
there.
network. I think it's network, sir.
Yes. So technically, when you go deeper, uh, problem, as I said earlier, security field is something like a dam again. So for a person who is securing a dam, he has to secure the entire dam. But if a person who wants to break a dam, he just needs one particular weak point, just like that. So it's not only either code or network, it is both, but always the attack comes from network, because only if an attacker can reach your endpoint, only when attacker can reach your website, only when he can scan all your open ports, only then he will be able to attack it. If you are able to identify attacker bit early, if you identify him with the help of some security technologies that we're going to discuss in this session and block him before he is doing some mischievous activity, that time itself we can block it. It's as much similar to what our army people do in our border. Before a terrorist enters into our territory, they will shoot him out, right? Because they were just trying to avoid the occurrence itself in the first place. This is what we're going to do in security as well. So security breach can happen by code as well as network, but the starting point is network.
Network.
So let's see. Let us take one scenario here. So now the FinServe is no longer just a startup. It has become a good company. It's a big company. Okay. Now in this big company, there's a CEO, there's a security head, there's an IT head, there's a CTO, everybody's out there. But out of uh, out of the blue, someday, one day the CEO finds out that he is not able to access the company website. The morning he just wakes up, he just opens up the app, the app says not able to connect. Or when you try to open the website it says unreachable. Now, from your understanding, guys, what could have gone wrong?
Maybe it's denial of service.
Okay, one possibility. Good. Any other?
DNS hack.
Could be DNS hack. Yes. Anything else? Okay, let's go with the same pace. In either case, it could, let's assume that it could be anything. Let's figure out that later. But right now, it could either be a DNS attack, it could be a DOS attack, it could be any other attack. Now, how can I troubleshoot it? How can I come to know what has gone wrong? What is the first phase of troubleshooting when it comes to these kind of issues? How can we check what has gone wrong? Any idea?
Using intrusion prevention or detection service IDS.
But right now the website itself is not accessible, no, ma'am.
Okay, so sorry.
I don't know whether the website is up or not. That only I don't know. Now, again, to handle this, there's a very basic way how life works, or even math works. So we have been learning this from our childhood, that to break a problem, to solve a problem, you have to break it into pieces, and you have to go to the basics of it. So let us go deeper and learn about basics. I mean, obviously, we don't need to learn it. It's all in your mind. We'll just revise it. The basics, the very base fundamentals of anything that happens in IT is nothing but OSI model. Okay, so OSI model is the very base of it. You can also call it as ABCD of network or ABCD of IT, because everything that we talk in IT or network or security in the later part will start from OSI layers. Okay, so OSI layers are, again, just to recall, it has 7 layers, layer 1 to 7. Fortunate or unfortunate, it starts from bottom to top. So layer 1 would be physical, data link, network, transport, session, presentation, application. Now I'll not go to the details of it, not the nitty-gritties of it. I just brief you about what all aspects are present over here. So the purpose of OSI model, when it was created, is to ensure that we have a standardization in the whole communication. So for any troubleshooting on communication, we always go from the OSI layers. We just check from bottom to top as per OSI layers that what all has happened. So first and foremost, let's say if for a CEO, his website is not accessible, is it because of his, it can also be he does not have internet connectivity, is it? Just because my Wi-Fi is not working, I cannot say that Google is not working, isn't it? Just my Wi-Fi is not working, which is a part of physical layer, right? So I can just confirm that is it only FinServ website not accessible, or any other website is not accessible? We always use Google for that purpose, isn't it? We just go to Google and say, is the website up or not? So firstly, we'll go check the physical layer. Physical, your cable is working fine, your modem is working. Then we go for internet, whether the internet is coming up or not. That is when we go for ARP, we go for DNS, we go for HTTP, we go for ATLS, all those aspects. So OSI model generally basically tells you about what are all the different layers that can go wrong and how can troubleshoot it. Okay, that's the purpose. And even OSI, there are various protocols that lands up in different layers of OSI layer. The protocol, technically speaking, it starts from data link layer, because physical layer is all about your multiplexing, your cables, hubs, and so on. In terms of layer 2, your L2P, STP, PPOE configurations would come up. Layer 3, network layer, is where your BGP routing protocols, ping protocols would come up. Transport layer is where your TCP, UDP would come up. Session layer is where your NetBIOS and other session-related protocols comes up. Presentation layer is where your actual encoding, decoding, encryption, decryption comes up. Finally, application layer is where your interaction happens. To break it down more further, each layer will come up has its own functionality. If you go from top to bottom, when the data is being sent from the sender to the receiver, the interaction of the application to the user happens at the application layer. The actual data is taken to the system, whereas with the help of multiple protocols at the application layer, it is forwarded then to presentation, where it encrypts, encodes, then sends to session layer to perform the to treat the delete and delete session. Then it goes to transport layer. Transition of the data is addressed. Then it goes to network layer to identify the shortest route and efficient route. delivery path is identified in network layer. Data link layer is used for error handling, error reduction, node-to-node transfers, synchronization of the frames. Physical layer is the way how the actual data is transferred in a physical format, whether it is via light, voltage. Light is optical fiber, voltage is your other cable, telephone cables, modems, all those aspects. When at the receiver end, let's say if I'm receiving data from somebody or some of a friend, the data comes to me first from a physical layer as a form of signal. Then to data link layer, the error detection is done. Via network, the proper network routing is done. Transport layer, the proper data packet synchronization or segmentation is done. Via session layer, again, the managing of sessions are done. Via presentation, whatever has been encrypted will be decrypted. Whatever has been compressed will be decompressed. Finally, to the help of application layer, whatever application traffic that I've got, whether it is HTTP, SSH, Telnet, whatever it is, my right tool will be able to capture the data. So this is in a very simple nutshell. This is a way how OSI layer works. Before we proceed, any queries in this, guys? Any queries in the OSI layers and its protocols? Any queries from the base OSI layers, guys? Great. Now, we all have learned OSI layer in our college, in our learnings. But what also OSI layer suffices is the attacks. Just like we have different protocols in OSI layers, similarly, we have various attacks also happening in OSI layers. Now, again, a standard disclaimer, this is not an exhaustive list because security is a vast, vast ocean. It is bigger than Pacific Ocean or any other ocean or any other combination of all the 7 oceans here. Okay, there are a lot of attacks happens. Like in terms of physical layer, the attacks like wiretapping, hardware tampering, power loss, something called side channel attacks that happens usually. All these attacks happen at physical layer. When it comes to data link layer, your MAC spoofing, ARP spoofing, we spoke about MITM attacks in a previous session. The root cause of MITM or the main purpose to perform the MITM attack, that is ARP poisoning, happens in data link layer. Other attacks like IP spoofing, ICMP floods, routing attacks, this all happens at network layer. Similarly, transport layers where like sync flood, UDP flood, port scanning happens in transport layer. Session layer is where your MITM's upper layer data, the actual part where you steal the data happens over here. Presentation layer is where your encryption bypass, breaking of protocols, bypassing encryptions, all those SL strips also happens at presentation layer. And similarly, all the major attacks that we face in real world, like SQL injection, cross scripting, RC vulnerabilities, or other command injection vulnerabilities, all these attacks happens at application layer. And just like we have every attacks in each layer, we also have defenses in each layer. For SQL or WAF, input validations we can use. We can bypass, we can have a stronger encryption normalizations. Attacks, we can have strong session IDs, best cookies, validations in each sessions. For any SYN flood, DOS attacks, we can have firewalls. For any IP spoofing, routing attacks, we can have IPsec security, anti-spoofing filters, which can bypass or which can defend against spoofing attacks. For we can have dynamic ARP inspection or port nabbing to get your protocols over there, or you can have your static port addressal or port locking you can use for ARP poisoning and all. For wiretapping, we can have a strong shielding, physical access control, locked racks, and of CCTV for analysis, or it could be surveillance. All those aspects we can perform at each layer. So the context here is just OSI layer is not only for networking, which is a big myth that a lot of people have. It is a frame that will help you troubleshoot not only network attacks, even your security attacks as well. Okay. So before we proceed, any queries from anybody, guys, regarding the OSI layer, protocols, plus attacks in each layer? So in a nutshell, it says that to troubleshoot any kind of IT security troubleshooting, start with OSI layers. Okay. With that, so let's go to the next study, the first case study of this topic. So now we came to know the significance of OSI layer. The team did analysis, and through the help of OSI layer analysis, we came to know that the FinServ is facing a DDoS attack. It is facing a DOS attack from multiple attackers, because of which website is inaccessible. Okay. So the question for you, you remember that we have a firewall here, right? There's a firewall over here, but still there's a DOS attack happening. Why do you think, in spite of having a network firewall, why is my website facing this attack? Isn't just having firewall secure my website? Yes or no?
Okay.
Just having firewall will secure my website or
No, sir.
infrastructure?
Compromise in authorization.
No, because the requests
Yes.
are coming from the different machines. So firewall can block the request
Yes.
from single machine, but if it is coming from multiple sources, it is difficult to detect.
Okay, this is I would agree half on it, but firewall can still bypass your DOS attacks, but not only because the data is coming. The only difference between DOS and DDoS is that DOS is an attack where it is done by one person to one server, whereas DDoS is distributed to multiple people from multiple attackers. So feature in firewall, if it is enabled from a region specific with a packet instruction firewall, even if the packets are coming from, even if a DDoS attacks are happening, the firewalls do have a capability, at least the firewalls that we have in today's world do have a capability to block DDoS attacks. When you're talking about capabilities, yes, will it DDoS attack? But but people can still go through DDoS attacks. But that one particular point that you said about if the coming from multiple places, that cannot be blocked. But that feature does exist in today's world. We can solve that. Okay, so that's not the root cause, sir. Straight on that. Yeah. Okay. Any other answers? We'll go. So yes, both answers were right. So just having a firewall does not make you secure. Why? Because this. Okay, I hope you would have seen this a lot of times, especially in COVID times and other cases. That you are having is as good as your configuration or your rule setting. Okay, if you are having a firewall in your server room, if you are not configured it better, there's no use. Okay, it is just like bringing a cat which has complete tolerance, 100% tolerance towards mouse. If a cat is a friend with a mouse, then obviously it does not catch the mouse, isn't it? It does not catch a rat. There's no point of getting the cat inside to catch overload of a mouse, isn't it? The same as firewall. If your firewall is not configured properly, then your whatever attacks that you're going to do, it can block. It cannot be blocked. Okay. So the answer to one of the question is yeah. So a firewall can block DDoS attacks if it is from multiple sources also, but you have to enable the rule set. In most of the firewalls, like something called AWS Shield, where you can something but the same thing, a firewall only, where you can configure it. So by default, if you just have Shield, because AWS is a managed service, it can do it. But if you install a firewall even if you install a very strongest firewall in the world in your organization, but if your configuration is bad, if you're allowing everything, just like this guy, what he's doing, he's not even checking anything, he's just allowing everybody, just with the normal basic inspection. He's not even checking whether this guy is having any arms or is there any other threatful thing that he has. He's just just bypassing this like that. So your firewall depends on your rules. If you have strong rules, it can block. If you don't have any strong rules, it cannot be blocked. As simple as that. Clear, guys? Any queries on this? Yeah. So basically, your firewall works like a guard in your gate. Whatever you tell it to do, it will do. If you don't tell it to do anything, it will not do. As simple as that. The basic function of a firewall, what it does, what all the incoming traffic, it will inspect the traffic. Whatever is coming, it will inspect the traffic. Whatever rules you have set, you want to allow traffic coming to port 80, it will allow. So what will happen if you're you should just read this particular rule. Here it says allow port 80, 443, port 22, SSH, and deny all others. So what this firewall will do is any traffic or any data that is coming, from any data that is coming from a particular port that is coming towards particular port 80, 443, and 22, it will allow. If any other request is coming to any other port, it will by default block. Simple as that. Is this clear so far, guys? Okay. Yes. Okay. So what this does is, so if any request is coming from port 80 to port 80, 22, and 443, it will allow. Anything else port comes, it blocks. So let's say if I'm sending a request for RDP, okay. If I'm sending a request for an RDP port 3389, it will block. But if an attacker is sending a request on port 80, it will not block. Okay, that will be the next part. But basically, your firewall will only see what all the configuration it is set. Only that configuration it will allow, and what all configuration it is set as deny, it will automatically deny everything. So it is just like a watchman or security guard. If you've told him that whoever is entering the college with the ID card, allow him, and whoever is not wearing ID card, don't allow him. As simple as that. So what he will do, he will allow all the students who is wearing ID card. If some student is wearing ID card of his friend, he will still allow. If there's any person who is an intruder, who is not a student, but is wearing an ID card, he will still send, because the instruction given to the security guard is that whoever is wearing an ID card, allow him. So it is a configuration issue. It is not a functionality of a firewall. Is that clear for everybody? Functionality of a firewall? Frankly speaking, one query regarding this, is there any other way to launch firewall DDoS? There are multiple ways to DDoS. That's why I was saying about security is not just one thing. There are a lot of things that can happen in DDoS. So a DOS can happen two ways. That I'll explain in a next slide. But just keep in mind that DOS can happen two ways. One, it can happen through a flood. If you go back to our previous slide, where we saw attacks, yeah, this one. So through ICP flood also, DOS attack can happen. Through UDP flood also, DOS cannot happen. SYN flood also, DOS can happen. And there are also other DOS attacks that can happen through application layer protocols also. Okay, so there are multiple ways DOS and DDoS can happen. Okay, yeah, both DOS and DDoS, both distributed DDoS service. I mean, the only difference between DOS and DDoS is that DOS is where you have one attacker. Let's say from an attacker, if I try to perform DOS to a particular, if I try to perform a DDoS attack to a particular what's it called, website, okay, some XYZ website, okay, that is called DOS, only me. Instead of that, what I'm doing is I am trying to perform, I'm sorry, just give me a moment.
So it is depending upon which service layers we are targeting.
Yes, we can say that way. But it also depends on your this case as well. What vulnerability, how the security posture of that particular system, all this matters. Not only about traffic, it matters your what application you're running. Is that application have any loophole? How the packet processing is happening? All those. Both matters. Was the answer clear?
Yes, sir.
Let me again, rephrase. So basically, what happens in terms of DOS? So DOS attack can happen two major ways. You can classify, if you want to classify, there are two classified ways. One is through floods. One is what I will do. I mean, basically, what it does, DOS is nothing but an attack where your system says I can't do it anymore. It's just denial of service. It is denying it cannot do its job. Okay. So there are two ways of doing it. Anything that is with flood, ISMP flood, SYN flood, UTP floods, what you're doing is you're giving too much amount of work, too much of packets you're sending to that particular server, so that your server is busy with handling those 100, 1,000 quantity or millions of billions of packets. It is saying I cannot do it. That is one way of doing it. That is flood. There's also application layer traffic. That is, I am confusing that particular server by sending a different type of data. Okay, that don't need to be a volume. I don't need to send 1 million or 10 million packets. If I just one packet, by changing certain by crafting a packet in such a way that my server does not understand, I'm confusing the server to handle my packet. That is also one way of doing that. DOS. This is also possible. Is that clear, sir?
Yes, yes. Is it also possible that depend upon the license type, some organizations are buying license to handle only some sort of connection at the same time? But if the connection is exceeded on that level, then also it is launching the DDoS attack.
Yeah, that is something which is configuration. Yeah, that can happen. It would result in DOS, but it's not an attack, no. It's just a configuration. It's because of your configuration. It's not there's no attacker who is attacking you. It's because of your license got exhausted. You're not able to do your job.
Okay.
Is that the user license you're asking about, or the firewall license you're talking about, sir?
I'm talking about firewall license.
Acha, okay. So let's say if a firewall is taking the license for using 10 million packets, and let's say if
Yes.
the firewall is facing 1.5 million packets, then firewall is allowing the DOS to happen. Is that right?
Yes. Yeah.
Yeah. This is where these are real world conditions that can happen. That is why when we are purchasing a license, it's not only in terms of firewall. It can happen in multiple places as well. Let's say, take an example of AWS Cloud. Let's say you are creating a container service like Kubernetes service or Elastic Container Service or any other managed service. Okay, you purchased this service to handle, let's say, 10,000 requests per second. Okay, and because of Big Billion Day or some other offer, there are huge number of requests which is exceeding this 10,000 requests. Then automatically it will result in DOS only. Sorry, DDoS or DOS only. That's the real world case. Does that answer the question, sir?
Yes. Thank you, sir.
Great. Wow, great. That's on the firewall. Now let me give you an example of how this firewall rules look like. So again, this is a very simple example request only. This may not be a real world firewall rules. You will find at least hundreds. You'll find firewall rules in the quantity of hundreds. If you go to AWS Shield or any real world production firewall, you will have hundreds or more than that rules. And more precisely in today's world, firewalls will not have single rules. It will have rule sets. It will have category based rules. Let's say, for example, for SQL injection, you will find like 25 different rules. But all these SQL rule sets will all be called as SQL injection rule sets. Similarly, you will have brute force rule sets. You will have XSS rule sets. So there are 100 different ways to do SQL injection. So your firewall rule set should be able to track all these 100 different ways of doing SQL injection. Similarly for process scripting, similarly for port scanning, similarly for IP spoofing, similarly for DDoS. Okay, there are different ways. Okay, so there are different ways of doing that. So each layer or for each attack, we will have different sets of firewall rules. Whatever I've given here are a very simple example. Let's say, for example, for DDoS attacks, you can have rate limiting, limit any connection which is more than if the same device is sending 20 connections, more than 20 connections per second, it should be blocked. Let's say if somebody is sending more than 5 incorrect login attempts, the packet should be blocked. If somebody is sending a script tag in your HTTP request, it should be blocked. If somebody is sending so and so payload, it should be blocked. So this is an example. So like this, you can have hundreds of different rule sets. Okay. So far clear for everybody, guys? Any queries? Great. Let's go next. So now the team has identified, hey, yes, they were doing a DOS attack, and they found out that there was the firewall was not configured properly. There was no rule set. Now they have the rule set there. Now the website is up. The website is available. But what happened is, after the website is up, the content looks different. The website totally looks different. Website is related to somebody else. The database, certain data in the database is deleted. What could have gone wrong? Okay. Even if after having firewall, are we still got hacked? Is it possible? Even after firewall, can we still get a hack? Yes, no? Yes, definitely yes. So as I said earlier, a firewall is just an inspection device. Just an inspection device. If somebody is, like just an example, take an example of a security guard only. So you have told the security guard to check all your students. Only the students who are wearing ID card, only the person who is wearing ID card should be allowed. What if a gunda or anybody, any person who is not a student, just wears something similar to an ID card? He just steals an ID card from some of his from some of your student, and he just enters. It is definitely possible for him to enter your premise. Is it not? Yes or no? Is it not possible?
Is it possible, sir?
Okay. So same thing happens in firewall. So your firewall, in this case, let me take an example of the same rule set. In this rule set, I'm saying that allow port 80, 443, and port 22. Right? What if an attacker has crafted a packet, a malicious packet in port number 80? Will it allow or not allow? If an attacker has crafted a malicious packet and send it through port 80 only, will it allow or not allow?
Yeah, will allow.
Yes. Yes, exactly. Because your firewall, you have configured a firewall to see only whether these ports are there or not, whether the packet is coming to these ports or not. It does not go out of that. Okay. So that does it mean we cannot detect and prevent it? Yes, definitely we can detect it and prevent it. That's why in security we call it as defense in depth, multiple stages of detecting malicious activity. That's why we have something called firewall. So basically what happens, this is what the root cause is. A firewall, if the data is coming on port 80 or if it is coming on a particular traffic in a particular port, which is allowed port, it will still allow. So it will not inspect the content inside the firewall unless until it is defined to. That is why we have something called IDS and IPS to do the job. Okay. The purpose of firewall is to inspect the traffic and block the unwanted traffic or malicious traffic. But there might be some traffic or the data flow can be morphed in such a way so that it can bypass the traffics. That is where we use a concept of IDS and IPS to identify the malicious activity. The purpose of IDS and IPS is which is called as intrusion detection system and intrusion prevention system. The purpose of the system itself is to identify malicious activity. So they will have signatures of how does it look when an attacker hack your system, when somebody is hacking your database, if somebody is sending a malicious request to a database. Even though it looks good, it looks perfectly okay for a firewall, it will be caught in IDS and IPS. Okay. So what is IDS and IPS? IDS and IPS are the type of device. Again, it's a security tool technology which will look the pattern, which will look into the content of the data, look for the pattern for any malicious activity, and if it finds any malicious activity, it will take action. Now, there are two ways. Both the basic principle of inspecting the traffic and taking action is same for both IDS and IPS. Whereas IDS is a device that is just like a CCTV camera. It will identify if there is any malicious activity. It will alert you. It will not do anything. Whereas IPS is something like a security guard. Okay. If it finds any malicious activity, it will go forward and block it. Okay. It can take actions. In the most simple way, IDS is just like a CCTV camera. Again, it will only tell you that something goes wrong. It will not stop the occurrence. It will never stop the occurrence. Whereas IPS is a security guard. He will try to identify, and whatever he can do, okay, whatever he can do, he will try to prevent it. For example, let's say, take an example of a bank. In a bank, every bank in today's world, we have a gunman. Okay, so if some intruder barges into the bank wearing AK-47 rifle, holding an AK-47 rifle, obviously he is no match to a security guard, isn't it? But does that mean security guard cannot stop it? He will try his best to stop it. Okay, he will try his best to prevent it. But whereas in terms of CCTV camera, it will not stop. Same thing in terms of IDS and IPS. IDS will alert you that something is going wrong, but it will not do anything else. Whereas IPS is something like a security guard where he will tell you that there's something going wrong, as well as he will tell you that he will try to block the traffic as well. Okay. So far clear, guys? So far clear? Any queries until now?
Sir, in organizational network, whether they use IDS and IPS in combination or they use individually?
It is both in use in combination, sir. In the real world, it is used in combination only.
No, sir. You said like IPS will detect and act, but IDS will only detect this one.
Yes, yes.
Then what is the use of IDS there?
Yes. I was expecting this question. Was that yeah? So usually, what happens in the organization, there can be certain false positives that we generally say. That is why, in generally, IPS rules and IDS rules will not be all same. Okay, even though we say that IPS have a capability to block or malicious traffic, sometimes there are possibility that because no tool is a foolproof tools, right? Tools can also make mistakes. That is why whatever issues that you know for sure this is a malicious activity, that connections will be appended to IPS and it will be set to block. Whereas any doubtful issues will be going to IDS. So IDS will identify an issue. It will inform to the SOC team. SOC team will take an action later. Okay. The purpose of IDS and IPS, why it is used in the organization in the combination is IDS is usually installed at the gateway level. Now you have to understand where it is installed. Let me go back. Now, if you observe, just closely observe the image. Okay. So startup network firewall, this input. Okay. So this input is where all the traffic comes in. Okay. And if you go forward, it goes to server and then it goes to payment request. One section goes to payment request, another section goes to DB request. Okay. So IDS is always installed at startup network level. Okay. Intrusion detection system is always installed at the gateway level. Why so? Because the organization wants, or everybody wants IDS to inspect each and every traffic. Okay. And here you may have true positive, you may have false positive also. But IPS will be implemented at the internal side here, DB level. Why? Because here, if somebody is coming here, if there's any request coming from server to DB, there we are sure because we are not allowing everybody to access DB, whereas we are allowing everybody to access the network firewall. So there are different stages where these devices are installed, sir. Does it answer the question?
Okay, sir.
Okay. So again, firewall, IDS, IPS, every tool or even if you may come across other tools, every technology and tools have their own purpose. but that doesn't mean that these tools will always be 100% accurate, because there might be false positives. That is why when we are tuning the rule set, we will tune the rule set in such a way only for which we are sure will block that rules, which we are not sure or which we want to alert, that we will keep it in alert mode. And what happens in real world is, whenever it's not like ideas will not block it, or ideas just because attack is triggered in ideas, it will not end up good. So what the way how industry works is, there's a separate team called SOC, Security Operations Center, or Incident Management Team, which also takes this aspect. So any logs, any such logs that is generated by ideas will be sent to this team on a real-time basis. The team will validate whether it is a false positive, whether it's an incident or not. They will validate and they will take action. So only thing is, ideas will take one step further. It will do the analysis. Whatever something that looks fishy, it will send it to a human. Human will take the decision. Whereas IPS, it will do it by itself. Okay. Great. So I hope so far clear for everybody. Any queries from anybody, guys? Yeah. Great. Yeah, great. So so ideas. Yeah. So now we are clear about that ideas, IPS, secure your the firewalls, all those concepts are clear. Now let's go forward to the other part. So basically, great. So now going back to our FinServ example. Now the team has pretty much implemented firewall. You have implemented. No, we have there's one query, sir. Is the IPS is based on AI? There are capabilities where you can integrate. In today's world, everything is getting integrated with AI. It's not the IPS is not a stop for that. Even IPS also, people have gone to an extent where you can integrate it to AI. Yes, I think in today's world, most of the vendors that we have today, they have a feature of this AI or processing. So what they do is the logs and decision making capabilities that you're doing right now. So these things are being integrated with AI technology, or more precisely the LLMs. So before taking decisions, it will look for the patterns. Whatever pattern or signature is identified by your tool, it will be sent to an LLM. There it will check for the pattern analysis, look whether it is true positive, false positive, and based on that, you can take. Again, this you can integrate it with not only IPS, it can also be done with IDS, it can also be done with firewall. There's also a concept called next generation firewall, which is not future, which is already there from a long time. This has more capabilities than your other stuff. Okay. Hope that clarified query. Now again, going back. So if you observe, compared to the previous image, so yeah, IDS is placed here and logging is placed here. Okay, great. Now going back to our scenario. So we have ID team. So now, if you look back our previous cases. So earlier our system was our system was with no IDS IPS. There was no firewall. The firewall was not properly configured. It was not encrypted. The plain text. So now, if you look from our first scratch, the startup environment to the current environment, if you look into, there's a lot of difference. We have changed the HTTP data to HTTPS. We have added the plain telnet data to SSH. We've added zero trust security architecture, zero trust security architecture, to segment different networks and authenticate and authorize each and every block request. We added MFA. We've done a lot of stuff. We've also added IDS and IPS and a lot more stuff. Okay. We have configured our firewall in a more effective manner. We have installed IDS and IPS, a lot of stuff. Now, is this secure? Can somebody answer? Are we secure? How much confidence can you say we are secure? Are we secure or not? So now you guys got confused? Are we really secure or not? Yeah. Yeah. So we have done our job to a decent extent. To some extent, we can say we are secure, but where we can ensure that our data is not feasible for MITM attack can be blocked. Your basic DOS attacks can be blocked. Your data stealing from plain text protocol can be eliminated. Yeah, so we cannot say that we are completely insecure, or we are saying that we are completely there, but we are just still some areas of improvement. So now what happens? So if you go back to this session's case study, so first the CEO found that the website is inaccessible. So when they went through the OSLA, they found out that there was a DOS attack or a DDoS attack, and then they tuned the firewall. After tuning the firewall, they found out that this website was defaced. Okay, I think there was also one discussion yesterday. Someone was also mentioning that their website got hacked, and whatever link that they click in the website, it was redirecting to some various website. Can somebody tell what could be the reason? What could have happened? That sounded interesting, which also links with our content here. Any idea? I mean, do you guys listen to that, or do we have that person who shared that experience yesterday? Website got hacked, where all the links were redirecting to a malicious website.
This is because of what you call it as a vulnerabilities in the operating system.
It could be, sir. It could be.
DNS poisoning.
It could be. So, yeah, DNS. So, see, what happens is DNS poisoning happens when you're trying to access that website, and that redirects to a malicious web page. But here, if you observe, the website, they are getting the actual website only, but when you click on that link, it is going to a different website. It may not be DNS poisoning.
It can be cross-site.
Site scripting, yeah. Process scripting can also be one other reason. Yes. So there are two
SQL
major reasons.
injection.
Yeah, explanation is for data. You're exfiltrating or
Okay.
manipulating data,
Yeah,
but
yeah.
yeah,
Sorry.
it can be
sorry.
process scripting. That's okay. That's completely okay. And there's also the root cause can also be operating system vulnerability. Definitely, we cannot rule out that. Any other possibility? Okay.
Attacker hacked through the SQL injection and he uploaded arbitrary code using which he changed all the codes, or he maybe uploaded the overlay.
Yes, that is also one of the possibility. That could be a proper chain of attacks that can result in that. Anybody know what is the attack called as? For instance, attack where website content is changed. Website content is changed. Any idea?
Defacing the website.
Exactly. That is exactly what I was looking for. That attack where the website content, the way how website is visible, that is changed. That attack is called as website defacement. Okay, website defacement. So website defacement can happen for various reasons. Okay, one of the core reason of that would be your operating system vulnerabilities. So to perform website defacement, the attacker should gain access to the source code of that particular website, or more precisely the server. Actually, she should get it. Or if he's using any CMS or content management system, if he let's say WordPress or Drupal or something like that, if he gain access to that particular system also, people can do it. Okay, so here that the root cause attack is called as website defacement. What he could have done, I mean, nobody knows what to have done, but the speculations only what we can do. One of the ways, as one of us said, he could have performed SQL injection and included arbitrary code, and on that we would have added overlays where the links were changed and all these things. That is one way of doing it. But for that, there are again its own dependencies. SQL injection vulnerability should be there, and the SQL injection database writing functionality should be enabled. This is a possibility. Second thing is if your website is operating system on which your web server is running. Let's say the web server is running on IIS, Internet Information Service, which is a Microsoft service, or let's say Apache service that is more commonly used, or Nginx or Apache, which is commonly used in Linux. To some extent, it can also be used in Windows also. So these softwares, let's say if my operating system itself has a vulnerability, like we had a couple of vulnerability, remote code execution vulnerability a couple of months before, or we can also go to the eternal blue attacks vulnerabilities also. If your operating system itself is vulnerable, then an attacker can compromise the operating system, gain access to your operating system, gain access to your file system more precisely, and from file system he can upload whatever file he wants and he can change. They're all one possibility. And one other reason what one of the members said is that cross scripting. Let's say if the content that is available on the main page, if that page had cross scripting vulnerability, you could have embedded. In cross scripting there's a payload specifically for redirection. You could have entered redirection so that the moment you open that particular website, it is redirecting to another website. That is also possible. Now, the reason why I pointed out here, let's take only these three cases. One is SQL injection and overlay. Second is your operating system vulnerability and exploitation to that. And third is cross scripting. If you go back to firewall, I'm just giving you possible ways of fixing it, or if your network would have been created in that context, even after having those vulnerabilities, you could have blocked it. Let's take example of SQL injection vulnerability. Let's say assume that even if SQL injection vulnerability exists in the system, if they would have had WAF in the system, the moment the person or the attacker would have tried to perform SQL injection attack, the moment he was sending a payload, that time your firewall would have blocked that request. Okay, that in one layer. If assume that there was no firewall, but there was IDS IPS, in that case, your IDS and IPS would have identified it. IDS would have alerted it to the system, and if you have had a good IPS with good confidence, it would have blocked the packet once again. That is on the SQL injection. Okay, let's come to the operating system vulnerabilities. Now, most of the operating system vulnerabilities, assume that it's a vulnerability from Windows. Most of the Windows operating system related vulnerabilities exploitation happens through port 445, which is SMB vulnerability, which is a major culprit for Windows. This could have observed. Let's assume that even if you have add this rule set, where your web server should only allow port 80, 443, and SSH, that is 22. This would have blocked, because by default, port 445 is not even enabled. So by default, whenever the attacker tries to attack, send a payload, so this would have been blocked by firewall. So if you have firewall, even if your operating system is vulnerable, even if your SQL database is vulnerable for attacks, if you have firewall placed, will pretty much block the attack. The first line of defense is always firewall. Okay, going back to our architecture here, that is why firewall is at the opposite, is at the entry point. The first line of defense is always your firewall. So after firewall, the second line of defense is your IDS. See, intrusion detection systems. Even though it can only identify, but it will alert to the respective user, through which they can take action of blocking that particular IP. They can just block the IP and put a rule set. Okay. Last is your IPS. Technically not last, but after IDS, you have your IPS, intrusion prevention system, which can act as another layer of defense to block such kind of attacks. Lastly, for process scripting, again, going back, same example of what we took with SQL injection. If you had implemented a WAF, web application firewall, it could have blocked then and there itself. Okay. Are these three understanding clear for everybody?
Hello.
Yes, sir. Please go ahead.
Sir, like this in this firewall, we have hardware and software implementation. Same thing. Like what about IPS and IDS? Whether it's a software implemented or hardware implemented, sir?
There are both, sir. Just like there's something called appliance. In real world, that's what it's called as. It's called as appliance. Firewall appliance. There's something called similarly. There's something called IDS and IPS appliance also. Frankly speaking, IDS IPS comes in two flavors. Firstly, there is an hardware IDS also. There's a software IDS also. A hardware IDS you can search for Fortinet. I think yeah, Fortinet is there. Cisco is there. A lot of other vendors are there who provides hardware as well. For software, if you look out, there's something called SNOT. SNORT. No, the slide is not moving, sir. Currently, it is in case study 3 only. I'm just explaining the vocally. In terms of software, there's a software called SNOT. Let me type it. SNOT is a pretty good IDS. It does also have IPS capability, but it completely depends on your configuration. I think there was another software, I'm not able to recall its name, for IDS. It's also famous for honeypot. I forgot its name. I'll just put it in the last probably. So Snort is one of the famous IDS IPS if you're looking for, which is a software based. Okay. So coming to the context, yes, IDS and IPS, just like a firewall, can be hardware, can also be software. Again, it depends upon the company's budget, how much they can invest, what is their configure. Yeah, OpenSense is also one of the good IDS IPS. But I think there was something starting with K, if I'm not wrong. There was one famous IDS IPS which was starting with K. I forgot its name. Just said IDS starting with K. I forgot its name, not K-Sense. K-Sense, no, there was one something else. I'll just punch it out whenever I recall it. Okay. Yeah. So yeah, that's the case. So pretty much in terms of real world, we can have it in both hardware and software. When you're doing it with hardware, we have it dedicatedly hardware for it. When it is software, there are two types again. Even in software, there's something called host-based IDS IPS. And something called what's it called? Network based. Yeah, network based. So it's also called as heads and hips in short. Host based IDS and host based IPS, and something called NIPS, that is network based IDS IPS. Network based intrusion detection systems and network based intrusion prevention systems, which is also called as NIPS and NETs.
So as an organization,
yeah,
as an organization, how we can decide that like we need both firewall, IDS, and IPS? On what basis or what criteria we can decide like?
So ideally speaking, if you're an organization, so let me tell you what happens in real world. So if a company, let's say if I'm a CISO, okay, if I'm a CISO of an organization who takes all the security decisions, and I have a budget, so my business tells me I can use whatever budget they want. They are allowing me to do even 10 billion for CISO budget, okay, and the business that I'm handling is a banking sector, which is very critical, and we can have very less amount of downtime. So what I'll do, I will purchase all three. I will purchase a firewall. I can go with multiple firewalls, a network firewall, a web application firewall, and a firewall dedicatedly for DOS, DDoS, and all those things. I will also put a host-based intrusion detection system, which will do a deeper packet analysis. I will also go for host-based intrusion prevention system, which will do a deeper analysis. But only if I have a big budget, only if my business requires very critical and less downtime structure. Similarly, if I'm a CISO of an organization like a Udemy, or let me not take a name of Udemy, or let me take any other very simple application which has like a Wikipedia, where even if a downtime of 2 hours is fine. In that case, even installing a firewall, I have to think twice because my budget will be less. So it all depends on the factors of what is the budget of a CISO and how critical the business is. So based on that, we will have different ranges of technologies and devices. Does that answer the question, sir?
Yes, sir. Yes, sir. Thank you.
Great. Yeah. So right now we are going back to our case study. There was a lot of informative diversions, but still. So coming back to our case studies, going back to our FinServe application. So FinServe application to some extent is pretty secure now. But so while the IT team is taking a time of relief, there's one pop-up that comes up. The moment the pop-up comes up, let's go ahead. So there's an insider threat detected. There's an unauthorized access. There's some warning. So as I said earlier, every organization, every logs, every activity is being recorded, and it is sent to a team dedicatedly sitting and analyzing their traffic patterns. Okay. So let's assume what this insider threat. Let's understand what is insider threat detected. Can somebody give a guess what does it mean when you say insider threat or unauthorized access internally? What do you mean by insider threat or insider attacker? Insider attacker.
Someone from the organization, like inside person, is infected due to some virus, and that machine is attacking the internal machines.
Yes, nicely put. It could be that, yes, or in a same context, somebody who is inside the organization is performing an attack. It can be either ways. The base concept is the attack is originating within the network. That is a base perspective, but it can be an attack originated by a person knowingly, where he is performing the attack, or his computer is compromised, and from that attack is happening. That's the case. Now, how do you block it? How do you secure from it? An idea? Yes. Again,
For that, we
just
need
like
to
other,
install host-based intrusion detection system.
but host-based intrusion system, you cannot. Host-based intrusion system is nothing but an individual host which will decide each and every packet and send you. Yeah. So in a nutshell, yes, that could be one of the solution. But for that, you have to install IDS in. Let's say you have 5,000 employees. You have to put all the 5,000 employees this devices, which will definitely make your system slow, network overhead in detail. So technically it is yes possible, but very load consuming as well as very resource consuming in both network load as well as system load. Okay. But that's a possibility, frankly speaking. Yes. So yes. So let's go back. Yeah. Just like every other concepts here, we will also about not one technology, but two technologies, how you can prevent and limit inside attacks. But base concept is inside attack is nothing but, or inside threat is nothing but a threat or attack happening originating from the system within the network. Because usually all these attacks that we have right now, the firewall is looking for incoming traffic. IDS or IPS will be analyzing incoming traffic. To some extent, IDS or IPS can also detect internal stuff because it is anyway inside the network. That's why I said IPS will be deployed right inside, right before DB. Because even if somebody is within the network trying to access DB, it will identify that. That is how this attack has been identified. Let us see the description of the attack. What had happened is a DB user, a DB admin, who is this admin, was his credential was compromised. His credential was compromised, and because the attacker has logged in to his corporate network, and he was the one who was trying to deface the website and delete the database. This is why I picked the example that of somebody telling website defacement story yesterday. It's also one of the possible way of occurrence, right? Somebody's credential from the system got hacked, and the attacker has logged in using his credential. Now, in real world, guys, this type of attacks has been occurred 100 times, more than 100 times. There are a lot of times this has happened that some credential of some guy, some of the employees was got leaked, and from that attacker has taken and logged into different systems. Okay, it has happened to even Kaspersky, not now, but very long ago. One of his there was a malware infected in his system, because of which the entire organization was hacked. The data was exfiltrated. A lot of things. Okay, so which means that not only we have to secure our perimeter, that is your network, we should also be very cautious when somebody from the work from, take an example of work from home, right? So when you're working from home, even the employee, whoever is the employee of an organization, even though is an employee, even though he's sitting outside the corporate network, he still be able to access the corporate resources or internal resources. Okay, what if somebody compromised his network? Okay, which is the actual example here. So here the attacker has compromised the network of the user, and he is the one who is performing this malicious activity. But it seems like because he's in a network where an employee is residing, it looks like the employee is the one who is doing it. Okay, but before going forward, is the base concept clear? What is attack? Is that clear? Everybody, what attack is being happening? Is that clear? Yeah. So here,
Yes,
the employee or the system user, official user, he is compromised because the attacker is using his network. Now, how can this be eliminated? Now, this is where we have a concept. So, how can I secure a corporate network? Okay, this is where we have a concept called VPN. So, you might have heard about this multiple times. If you have anybody who is doing work from home in your family or nearby, you might have heard that they have to connect to VPN. Okay, so VPN is a concept where, or basically stands for virtual private network. It's a concept where a remote user, let's say for example, my office is in Bangalore, okay, but my native is in let's say Coorg, okay, or let's say my native is in Delhi, okay, my office is in Bangalore. So for some reason, for some emergency, I cannot go to office. I'm in my native, and there's an emergency work that I have to do. But this work can only be done if my computer is in within the corporate network, because there's some security rules which can only execute within the network. Okay, this is where we need something called virtual private network. And what is the meaning of that? So basically, from Delhi. Sitting in Delhi, I cannot make private request to office which is there in Bangalore, right? So I have to use internet only. You cannot bring a line, draw a cable from Delhi to Bangalore. Right? It's not possible. It's not feasible. It is possible through optical fiber cable, but still, it's not feasible to the cost, right? So that is where we use this concept called VPN, where you are creating a private network, intranet, sorry, a LAN network or a private network with the base of a public network. Okay, so even though I'll be using internet, okay, even though I'll be using internet sitting in Delhi, I can send packets in such a way as if it will seem coming from Bangalore only. Now, how is this possible? Basically, I'll be using something called VPN client and VPN server. There will be a small software sitting inside my laptop, okay? And whatever data I am sending to my server, which is present in Bangalore, all this data will be encrypted. It is doubly, you can call it as tunnel. That's the right way of doing it. There's an outside tunnel, which is obviously HTTPS or the basic your any other encryption like IPsec and so on. And inside that, my traffic goes. So anybody who even is a part of my network, okay, they also will not be able to get my data, because the packet by default, when it is originated from my system itself, before going out of my system, there itself it is getting encrypted. Okay, so again, let me repeat: virtual private network or VPN is a concept where we can make a private network. We can send the data in a private network with a base of public network, which is internet. Okay, how can we achieve this? We can achieve this with the help of VPN client. the small software that sits on my laptop. When I turn on and route my traffic through that particular software, it will send it directly to the corporate server, which is located in Bangalore, through encrypted channels. That is what is called as VPN in a nutshell. Okay, is this clear for everybody? What is VPN? What is needed? Is the VPN clear for everybody, guys? Great. Okay, there's another concept similar to VPN. There's another concept called
Virtual.
DLP. Yeah, please go ahead. Yes, ma'am.
Sir, are there chances of like threats in VPN also? Attacks?
There are possibility. Yeah, I mean, nothing in the world is attack free. If your VPN server, let's say we have spoken about VPN client here and VPN server, those also can have a loophole or vulnerabilities. So if a VPN client has a vulnerability like Cisco Connect, Cisco Connect is one of the VPN client. If that has again it has its own vulnerabilities as well. OpenVPN also has a lot of vulnerabilities. If these vulnerabilities exist at the VPN client level or VPN server level, yes, definitely it can get hacked. Okay. So, hope that query was answered. Yeah, somebody else was also asking a question. Please go ahead, ma'am. Okay. Okay. Yeah, we can also ask queries later as well. So we'll go forward. Okay. So there's another concept called data leakage. Now, what we discussed is one way of doing it. So what if employee of an organization is compromised? That is what we saw in VPN. Now, what happens if the employee wantedly or purposefully tries to exfiltrate data? Let's say I'm an employee of an organization, ABC organization, and I'm very very disappointed with my organization for some XYZ reason. I have a lot of grudge with my manager. So whatever very important files that I have in my organization, let's say I have the audits reports, I have vulnerability reports, I have financial reports, I have access to all these reports or all these very confidential, highly confidential research specific USP related files information. What if I'm trying to move it to my personal drive? What can go wrong? What will happen then? Isn't it a threat for an organization? I'm not attacking the organization, but I'm trying to steal all the data. Technically not stealing, I have access to it, but I'm trying to moving out to my personal drive. Is it not a threat? Yes, no?
Yes, yes.
Any idea how we can block it, or what can happen here? What can we do to mitigate this? Yes, it is an inside threat only. Any concept? What do you think can happen? Can we do to mitigate this? Because that's what industry is doing. Industry they have this concept.
If I may
Yeah.
not wrong, it can we use strong encoding?
Encoding. Okay.
Strong
You want to say you want to
encoding,
encode that file?
yeah. So we can. So if data leaked, also we can prevent our confidentiality. We can stop the compromising the confidentiality. So up to my knowledge, I'm saying.
Yes, yes.
can
So
be-
before answering the question again, there's nothing called right or not, right or wrong, because we're all learning anyway. Nobody has complete knowledge on anything.
Sir, actually,
It's completely okay. Yes, go ahead.
I have heard that they are using application level firewall and they are not allowed anyone to open Gmail or opening such sites through which they can transfer the data, like specially uploading data. Like some of the organization, the peoples are uploading, they are not uploading the code on their server. They are making the email, they are drafting the email, they are not sending the email. They uploaded the code over there and at the home
Okay.
they open the same Gmail without transferring
Okay.
the data. They also take the data outside from the organization.
Okay. Can you reiterate the last point, because I think I missed the context in the last two lines. Sorry. I'm sure about one application level firewall that you said. After that, you said there's some code for the email which you can open in Gmail again. I
So
did not
basically,
clear.
so I have visited one organization. They told that what the most of the employees are doing, they compose the email in Gmail and they uploaded
Okay.
the code over there. So they are not uploading; they just draft the email and paste the
Mhm.
code over there.
Okay.
Now they are not sending any emails. They are not doing anything wrong. They just go to
Uh-huh.
their home and open that Gmail once again, and they get that
Okay.
drafted. That draft is already there because it is stored on the Gmail server.
Okay. Yes.
And they get
The
that.
attachment you're talking about. Attachment. Yes.
No.
So this is one of the
Yeah.
reason why, yeah, this is one of the reason why most of the corporate systems does not allow social logins. Most IT companies, unless until it is for marketing, you're not allowed to use personal Gmails. You're not allowed to use Instagram, Facebook, to some extent, even LinkedIn. That's the case. So this is, let me tell you, yeah, this is one thing. I think one of the ma'am also gave the partial information, correct? So before answering both the answers, let me give you the concept. In the industry, there's something called DLP, data loss or data leakage prevention or data loss prevention tool, and there's also something called IRM or intellectual right information right management. My mistake. Sorry, information rights management. It can be conclusive. It can also be inclusive. It can be exclusive. It can also be inclusive. Let me answer one by one first. Let me break things. So usually what happens is when you want to exfiltrate data, there are multiple ways. Okay. Let's say assume that I have reports in my PDF. I want to send it to my personal drive. There are multiple ways. One, I can use my USB. I can copy the file. What organization do? They block USBs. 99% of the time, all the corporate laptops, your USB will be disabled. So one chance is done. What are the other ways I can exfiltrate data? I can upload to my personal drive, okay, which is Google Drive. Okay. So most of the time, or again, same 99% of the time, your personal Gmails, inclusive of Google Drive, is not allowed. It is not application firewall. Again, it is the normal firewall only. Usually, as I said, there's a VPN client in your laptop. Similar to that, in today's world, in a corporate laptop, you have at least 4 to 5 different apps or 4 to 5 different clients, which is running in background, which will do all the filtering. Irrespective of whatever website you're opening, whether it is allowed or not allowed, the website's loading itself, because at the end of the day, when you open a website, the website will be crafted, it will go through your NIC only, network interface card only. So at the network interface card level itself, your app will block all the unwanted websites. So irrespective of whether you're using corporate internet or you're working from home, the website will not even open for you. Google Drive or Gmail will not even open for you on your on an official laptop. It will automatically be blocked by firewalls. Okay, that's one way of doing it. Third way is drafting an email and sending you, like what you said. If Google does not even open, obviously there's no point in Gmail doesn't even open, then obviously you cannot even create a draft. There's also a catch. This is all a concept of firewalls. Now the catch in terms of DLP or data leakage prevention or data loss prevention is at the media level. So what happens is in every file, there's something called metadata. Okay, so DLP is a software, a small software that sits on your laptop. Every time if there is any file going outside your network or outside your system, DLP agent, a small software, will automatically check all the data that you're trying to send outside, especially if you're sending it outside your organization network. Okay, let's say even if you draft an email from, let's say my office email is in Outlook, my personal email is in Gmail. The moment I say at gmail.com, it will scan my attachment I'm trying to upload. Okay. If it contains any confidential data, it will fast the data, even if it is encrypted based on your metadata. It will automatically block. It will not even allow you to send that file, and it will automatically raise an alert informing your management saying that this guy is trying to exfiltrate the data. This mechanism is called as DLP, data leakage prevention or data loss prevention. Okay, which will scan your files, and every time your critical files is going outside your network. It can be via email, it can be through chat, it can be through any other case. Okay, social media also. This will do it. That's the DLP part. That's the best way to fix it. And one of the things that Madam said is you encrypt the file, and the file cannot be viewed by any, even if they have a file, they cannot open it. There's a solution called IRM, Information Rights Management, which has a capability to do that. Okay. The reason why I said it's partial, it is not encrypting the file, it is encrypting the whole package. When you're sharing the file, it will not be only a PDF file, it will be a complete package file. Let's say if I'm sending the data to you, and if you are the authorized user, you will be getting a proper role-based access control RBAC related information in the metadata. Only you with your proper credential can open it, and only for a defined duration. After the duration, the file will become expired and you can no longer use it. Okay, so there are three controls that we discussed. One is blocking the websites at the firewall level. Second, websites like social login, Google, Gmail, everything. Second thing is a DLP. Each time your data goes outside your organization, you're uploading a file, you are sending an email, all those stuff, it will monitor and it will block that file transfer. Third is IRM. If there is any critical information that you want to share to somebody else, the information will be attached with an IRM. There's Microsoft 365 version of IRM. There are different IRM tools which will do all the policy management, give a validation, which user can use what data, until when he can use it, using what device he can use it. All this will come under IRM. Okay. Great. So was all these concepts clear for everybody? IRM, blocking of websites at the WAF level, DLP, is that clear?
Yes, sir.
Okay. Hope So role-based access control can be used to some extent, but the DLP and IRM will go to an extent. Even if the person has a right access to see it, he will still not be able to share the file because of the DLP. Okay. So how DLP works, it just looks metadata. It looks for it looks for classification of data, metadata, and what is in the content. All these look, it will verify, and then it will block the data. Okay. So with the help of DLP, data loss prevention or data leakage prevention, also is called as in certain cases, it can block any sensitive data going outside the network. Okay. So lastly, what is considered as a secure stage of a company? Let's say we started from a very base structure of a startup, which almost very less security. So we have implemented HTTPS on the website. That is, whenever or whoever accesses our websites, it will be encrypted. And earlier we were only having SSH, but we are ensuring that we are having VPN. So whenever a user connects to the internet even from work from home, his traffic is encrypted, not only by SSH, but also through VPN. And secondly, your login, username, password is done through username, password, and MFA, so that even if your password is compromised, your account can still be secure. Next, using zero trust architecture, whatever request, whether it is coming from inside the network, outside the network, it is all secure. Next, we not only have implemented firewall, but we also updated it with industry grade rule set. We have deployed IDS and IPS in the right architecture. Lastly, we have implemented DLP and VPN in your organizations at the right levels. Okay. Now, before the query, do you think FinServ is secure now after all these controls? What do you guys think? FinServ is secure now?
It can be compromised since there is.
I'll leave that decision to you guys. But one statement I can give you, that there is nothing called secured in the world of in today's world of digital ecosystem. It's only a matter of time that a website or anything that is secure can be compromised. Because let's say if you go 5 years ago, people were saying that zero trust network was secure. That time, latest Windows 10 is secure. Windows 7 and some other versions are insecure. Your RSA is secured, and a lot of other things. But go back 5 years later, that is 2026 now we have. Windows 10 is no longer secure, RSA is no longer secure, and a lot of components that we thought were secure in 2020 is no more secure today. So it's only a matter of time that you find out some vulnerability. It's only what we can do. We can't, so should we just leave our hands up and say everything is insecure? It's not like that. Security is not just a toggle switch that you enable or disable or implement something works. It's a culture where you implement multiple stages of technologies or defensive mechanism and ensure that all things works, and regularly updating yourself. Okay, so that's what was from my context, my topic. So thank you for your time. Thank you, Alvas, for giving me this opportunity. Thank you, Manjunath sir, and all the participants for being such a wonderful participant. Again, I'm just putting my email and LinkedIn profile so you can connect with this thing. And if you have any questions, any queries, please feel free to reach out to me. And yeah, you can also raise any queries we have right now. I'm sorry that you have taken another 8 minutes of yours, but yeah, this is how it is. Thank you all. Thank you for being good participants.
Okay, sir.
Thank you, sir.
Okay, thank you, sir. On behalf of all our Institute of Engineering and Technology, I extend my heartfelt gratitude to our esteemed resource person, Mr. Bharath Kumarian, for delivering such an insightful and enriching session on public key infrastructure, OSI layers, network protocols, VPNs, and many more. I also would like to thank all the participants for patient listening. Thank you very much, sir. Thank you once again, Bharat sir. Thank you.
Thank you, sir. It was great.
Thank you.